So, hello everyone. I hope you're all having a good day and thanks for joining us. So, before we get started, I would like to just introduce myself. I'm Amrita. I'm the lead for GDG Cloud KL, and professionally, I'm a technology consultant for the data and analytics team at Ernst& Young. Over here, you can see these two amazing girls with me. They're the organizing committee as well of DevFest 2021. So yeah, Z, do you want to say hi to our audience over here?
Hello everyone. I'm Hoji, the lead of GDSCUM, and I am a year two student in UM, currently studying at the Computer Science Artificial Intelligence.
Thanks, Z. And yeah, we also have Jingying over here. Jingying, do you want to say hi to everyone?
Hello everyone, my name is Jing and I'm a year 2 student studying software engineering in UM. Thank you.
All right. Thanks, Jing. So, yeah, thanks again, everyone, for joining us today. We have been looking forward to having our Dev Fest this year. I know we wanted to have it in person, but yeah, with the current situation, we want to prioritize everyone's safety. Hence, we're having it virtually this year as well. So, yeah, don't worry. We have planned it in a way that we can make it as interactive as possible. So for those of you who have already joined us, just tell us hi and let us know where you're from and what is it that you do and what you're passionate about. So let's have a conversation while we go through the entire day. So thanks again to all of you for joining us. We're super thrilled to have you all here. Yeah, before we get started, I just want to go through a quick introduction of who we are, because I understand that some of you are probably joining us for the first time. So, yeah, GDG Cloud KL is a friendly nonprofit community of developers working with or interested in learning more about Google Cloud Platform and other technologies as well. So we generally host events to create opportunities for amazing developers with similar interests to meet and share ideas related to technology. So we really value safety and security of our community members. So, bullying, discrimination, harassment, or any mistreatment by any person present will not be tolerated. So, we hope all of us could remain respectful to each other, to all participants, panelists, and organizers throughout the event. And once again, thanks for joining us. We're super thrilled to have all of you together for our annual Cloud Dev Fest celebration. Um, yeah, since we have just started, I know it's pretty early in the morning for a weekend, and I've understood that there are people joining us from different parts of the globe. So if it's still too early for you, we'll probably just take it slow to get started with our event today. Yeah, we would like to just share with you guys some stuff about our event today. So yeah, I'll pass it over to Z to play our video.
We've already started to see the difference we can make by working together as a community.
Yeah. Yeah. So understand that there are quite a number of students joining us as well. So yeah, please do mention that. I see that we have a student from UM, Mang Un Lee. Yeah. So it's amazing how you've also joined us today. Yeah. Over here. So thanks to all of you guys who are here. We're super thrilled to see you all. Yeah. let's get started with our schedule. We'd like to share with you guys what is our plan for today. So as you can see, this is our agenda for today. Yeah, so we'll be having the opening session from 11 a.m. to 11:30 p.m. I mean 11:30 a.m. So yeah, after that, we'll be having our first session by Gwenny. So, for those of you who are interested to host your own static site on GCP, I'm pretty sure this is going to be an amazing chance for you guys. And yeah, after that, we'll be having a lightning talk by Anandan. So, he'll be talking about transforming the language of life, where transforming neural networks for protein prediction tasks. So, for those of you who are interested in that, I hope you're thrilled about that. And after that, we'll be having a break at 1 to 1:30 p.m. So yeah, understand that with things virtual, we have a lot going on the social media and stuff. So yeah, let's just take a break from 1 to 1:30. But yeah, during that time we have some interesting things to share with you guys as well. So as mentioned, we have some giveaways today. So yeah, make sure that you stay tuned like throughout the event. We will be you know surprising you guys with opportunities to win these swags. And yeah, I can assure you these are some interesting swags that we have, to give away to you guys today. So yeah, stay tuned for that. Make sure that you um, stay with us throughout the event because we're not mentioning when we would be sharing about these um, swags that we can win. But yeah, it will be coming up every now and then. So yeah, make sure that you stay tuned. And yeah, once we're done with our break, we will be having our next session with Shweta. We'll be talking, Shweta will be talking about machine learning in production. And yeah, our final talk for the day, it's also a lightning talk by Jack from UM. So he'll be talking how not to code like a noob. So I think that's a pretty interesting one that you guys would want to join as well. So yeah, after that, we'll having our closing session. And yeah, that's it for the day. I hope you guys are thrilled about this as well. So feel free to share with us what is it that you're looking forward to. Yeah, see, we can move on to the next session. Yeah. Okay. Yeah. So we have to give our special thanks to our partners today. Without these partners, we couldn't have, done what we are doing today, and we couldn't be providing you guys all these amazing opportunities and, the speakers that we've brought in. We'd like to thank them, and we'd like to thank Google for providing not just an amazing platform for us to network and the amazing content that they're sharing with us, but also yeah, we're sponsored to give you guys the amazing swags that you could win today. So yeah, we'd like to thank Google for that. um yeah, Z, we can move on to the next one. All right, so let's just
Welcome to DevFest. I'm very excited to be with all of you today. I miss being able to join many of you in person, but I'm really excited about continuing to engage in this virtual format as we all come together to learn and share what we are all building. Thanks to the amazing Google Developer Group team for organizing this event. This incredibly passionate and enthusiastic group brings developers and local communities together to help each other learn and inspire at a time that we need to connect the most. In light of the past 2 years, we hope that this DevFest will inspire you to learn and connect as a community by exploring how to use Google technologies to build solutions to improve people's lives. Developers like you are the backbone of technology. You play an important role in the recovery of the global economy. On Google platform, developers build solutions that save lives. You've entertained us, addressed real-world challenges, made solutions that create jobs, and solve important problems in our world. The work of developers, your work, have never been more important. GDGs have always been committed to developers, community, and generating a positive social impact. DevFest is an opportunity for GDGs to show up for their communities. Let's talk about how being a part of this community will help you build your tech career. Learn with your community and develop your technical and applied skills. Your local GDG chapters run numerous tech talks, hands-on workshop, study jams, hackathons with a community of your like-minded peers. Join this event, attend, volunteer, share your interests and learnings, and help shape this community that you are a part of. This is a safe space where you can ask questions and learn from each other while learning new technologies and apply them to real life projects. Connect with others, build your network, support others in your community. Don't just attend and learn in silence. Connect with others at events such as this DevFest. These days, hiring decisions are made beyond what's written on your CV. Your online presence matters. Your developer profile, your community contributions, and engagement tell hirers if you are a team player and if you have a lifelong learning mindset. So establish your online presence where it matters, whether it's on LinkedIn or Twitter or community forums. Post and engage meaningfully with your peers. When you engage with the community or help someone to answer questions, you will likely learn something new too. Inspire others and showcase your expertise. Explaining a concept to others is a great way to solidify your learning and also to improve your writing and speaking skills. If you share your learnings with others via social media, your blog, YouTube, you can significantly help build your brand and authority in the subject. Apart from all these visible benefits, the process of creating tutorials also leads to increased self-awareness and insights about the topics. Share these projects with your local community. Speak at GDG events, ask for feedback, meet like-minded peers with similar interests. You never know what you're going to learn. As the famous saying goes, if you want to go fast, go alone. But if you want to go far, go together. I encourage all of you to continue to be in community with fellow developers and use the skills and technology you learn at DevFest, communities you've formed, friends that you've made to make a difference. Our goal this year at DevFest is to help developers like you be even more successful building with Google and help you drive change in your community. Your success brings about positive impact to the world. We want to give you a bigger stage and help tell your success story to a broader audience. Thank you for joining us today to learn, to connect, and to be inspired. Welcome to DevFest.
Amrita, you're muted.
Thanks. Thanks, Eve, for mentioning. Yeah, so for those of you who are wondering, that was our regional lead who has been supporting us throughout this entire process of organizing our events, and so Janice was unable to join us today. So yeah, hence the recording. So yeah, let's move on to our next community partners. So yeah, we have Turing. So Turing has been our community partner for Cloud DevFest 2021. So for those of you who are wondering, what does Turing do? So Turing.com is building a free and open global community of ambitious developers who aspire to build strong careers by working with the best companies. Turing bridges the gap between talent and opportunities by helping leading US companies find and hire the top 1% of the world's software engineers. So this drives the mission that Turing has set out for, which is to unleash the world's untapped human potential. So yeah, if you want to experience the remote work revolution, you can always visit www.turing.com/jobs to be a part of the Turing community today. I believe that many of our participants today have joined us through Turing as well. So yeah, we'll also be sharing the links to reach out to this amazing community as well. So thanks once again, Turing, for helping us out. Yeah, next up, we would like to thank GDSC over here for joining hands and helping us make this event happen. We have Z and Jingying here assisting me today, and yeah, it would be impossible to not have such amazing people around to have an amazing event like this. So Z, do you want to share a little about the GDSE community as well?
Yeah, sure. Thank you, Amrita, for having us in this DevFest. So, the Google Developer Student Club is actually a program presented by the Google developers, and GDSCUM is a university-based community groups for UM undergraduates and graduates interested in growing as a developer. And by joining us, students grow their knowledge in peer-to-peer learning environments. And we have done a few workshops and talks. And also recently, we're having a national Android development competition, and the submission deadline will be in February. And throughout this period, we are going to have some mentorship programs. So don't worry if you are a newbie. Yeah, we are here to help you. And also, we have also done some workshops for about Android, and the recordings are all on YouTube. And no matter what background you are from, you are welcome to join us. And for more information, you can just go to Instagram and search gdsc.um, and you can join us from there. Thank you.
Thanks a lot, Z, for sharing about this amazing community that we have. Yeah, so for students out there, wherever you are, it's not just GDSE there are many other GDSE chapters as well. So feel free to connect with them. And trust me, it would be an amazing experience for you as students and as aspiring developers. Trust me, it's a great platform to not just develop your technical skills, but also your leadership and soft skills. So yeah, feel free to check it out, and you can reach out to any of these GDSE leads and find out how you can be a part of the community and how you can build and grow your skills as well. So thanks once again, GDSE for being a part of this event today. Um, yeah, so we can move on to our session today. All right. So, yeah, we'll be starting our session today with our first speaker. So, before we get her to join us, let me just introduce Gwenny to all of you. So, Gwenny is a cloud engineer with a passion for DevOps, machine learning, and improving diversity and inclusion in STEM. So, she's a career changer who moved into tech after years in curriculum development, education, and way back music. So, in her spare time, she's learning to weightlift and is a qualified yoga teacher. So, the weirdest thing she likes is reviewing people's CVs for fun. So, let's bring in Gwenny.
Hello,
Hi,
everyone.
Gwenny. Thanks a lot for joining us today. I mean, I'm pretty sure that our participants are pretty interested to know more about your interests. Like, do you mind sharing? I mean, this is a lot of stuff that you're doing, and it's so, you know, inspiring. I mean, you're a GDE, you're a cloud, you're an engineer, and you're a yoga instructor. This is a lot of stuff. So, like, how do you manage all this?
Yeah, I had a weird journey into tech for sure, like a non-traditional journey. So anyone out there just interested in tech, I encourage you to consider it. I think if I can do it, like anyone can. I had a totally non-technical background, and I think that tech skills are all learnable. But yeah, for the yoga, I did that last year. I'm in Melbourne at the moment, or NAM. That's the Aboriginal name. So we had I think you probably heard, we had a lot of lockdowns. We were locked down basically all year last year, or half the year. And you couldn't really like go out except maybe 1 hour a day for exercise a lot of the time, or for groceries. So when I career changed into tech in 2019 formally, I just thought, oh, if I'm going to be kind of sitting all the time at a computer, I should maybe do something to motivate me to move, because I'm not motivated to exercise at all. So I thought yoga's good, and I like yoga for my mental state, because I get kind of really anxious and like sometimes depressed, and yeah, yoga's really good for managing that. So I just did a yoga teaching qualification. It's like 200 hours. I did 250 hours. And I'm actually not really doing it at the moment. I've been trying to do weights to get just stronger and like more toned, because I moved into this beautiful building. I'll show you Melbourne. Does anyone want to see Melbourne?
Yes, we'd love
Probably a
to.
bit bright. So that's Melbourne at the moment. It's very, very like misty day today, very hot.
Oh, it looks beautiful outside.
Yeah, it's very sunny. But yeah, so that's why I did yoga. And the resume reviewing, I don't know, I've just always been really into it, and it's weird, but it's still something I do for people. So if you want me to look at your profile, hit me up. Sorry, I'm just trying to find my charger.
Yeah, I think yeah, for those of you who have joined us today, so now you know who to send your resumes to, right? We'll be sharing more about Gwenny as well, like how you can reach out to her LinkedIn and stuff. So yeah, feel free to reach out to Gwenny if you have more questions about the talk today, or in general if you have any questions regarding a career in tech. Yeah, so before we get started, yeah, Gwenny, do you want to explain a little about, do you want to share a little on what you're going to talk about today? So I think that many of us are pretty interested, to learn how to host our own website on GCP. So yeah, would you like to give a brief introduction of what today is going to be about?
Sure. So I tried to think of a topic that would have a lot of wide applications for kind of anyone, really. I think it's really good to have your own profile or your own projects to talk about, particularly if you're earlier in your career or entry level or career changing like I did. So like a website or a portfolio is something that's really good to have. And you can always do like an informational website for something you're interested in, or like a blog to host articles if you just kind of write every so often something you learned and you keep a little like running tally. Like I work with a guy that does, when you see TIL, today I learned, he just does like a tiny little line each day on his blog, a couple of sentences about a command he learned or a concept he learned. So if you have something like that, it's really good to be able to talk about it. And I'm going to ask you when I start the talk a bit about where all of you are at in terms of cloud. But cloud is definitely becoming something, I think even devs, you just can't really avoid. You need to start developing like DevOps and cloud skills, whichever platform it is that you decide to use. I worked a little bit on AWS, Amazon Web Services, which is probably the dominant cloud provider. Azure is Microsoft's, and then there's GCP, Google Cloud Platform. I just prefer the kind of user experience of GCP. I like Google products, so I now work for a GCP consultancy that's a premier partner of Google. And I was just, thinking about what would be something that most people could use and most people could take away, even if they don't follow along with the demo today, but do it in their own time as well. So it's something you can do if you're new to tech, and if you're a total beginner, it's also something you can do if you're more advanced and you can take it further. So we're going to talk about how to host a static website on GCP. There are a few different ways you can do it. We're going to do it through a GCS bucket, so Google Cloud Storage. It's really just it's like when you upload files to Google Drive, you're uploading files into a bucket, which is like a storage container. You make those files visible to the public, and then you can point to a domain name. So you own a domain name, some kind of whatever the address is you want people to type into the browser, and you can set up that configuration and then serve a website that way. And it's a relatively straightforward way to start using cloud, and then you would have like a project to talk about as well with that's like a cloud native kind of setup. So that's really useful, something kind of extra if you're a developer to be able to talk to as well, or if you're interested in moving more into cloud.
So thanks, Gwenny, for sharing that. So yeah, without further ado, we'd like to jump into the session. Gwenny, could you just share your screen and we can get started with the session for today?
Yeah, no worries. Just going to do my entire screen so you'll see my billion tabs. Enjoy.
Right.
Is that okay there?
Yep, this looks good.
And it's gone like full screen, okay?
Yep. Okay. So I'll just drop off from this, and yeah, the stage is all yours, Gwenny.
Okay, thank you. I'll just check the time too. So oh, good, 2:30. So hello. I've already kind of introduced who I am a bit, but to give you, I like to talk about my background just for people that are non-technical or might be thinking about moving into tech, so that you're aware that you can become technical if you're not. The skills are totally learnable. And my LinkedIn link is there if you want to connect with me. Just say like, hi, I was at CloudFest, and yeah, that would be nice to talk to you. So I first career changed into tech doing web development. I did a diploma of IT. We have like a 6-month full-time boot camp here in Melbourne and in Australia. And that was it at the start of 2019. So we did like some HTML, CSS, JavaScript, and Ruby on Rails, and then MERNstack, which is like a JavaScript full stack library. I ended up, when I was doing that, feeling a bit confused why I might write something at an application level without knowing what else was working with that application, or how it was integrating with other services, or how the whole system was working together. My brain just kind of wanted to know that full picture of the whole ecosystem that it was in. So I did a first internship at one of the big banks in Australia, and I requested to be in DevOps. That was kind of hard. I was by myself and I didn't really have much support, but I did get to learn about DevOps, and that was kind of cool to learn about the different tools that get used in that space. And then I ended up interviewing for jobs and internships, and I took a second internship because it's at the place I'm at now, Kasna. I knew that their culture was really good, and it really mattered to me as someone new to the industry and someone who identifies as quite a slow learner. It really mattered to me what the culture was like, and that they supported learning and growth, and that they were also an inclusive company that was really respectful of everyone, and you could kind of be yourself at work, because I'd worked in toxic workplaces before, and I kind of made a decision I didn't want to do that ever again in my life. So yeah, before that I was in curriculum writing. I was writing course books. I was an English teacher for a long time. And before that I was a music teacher and a musician. My first degree was in like classical double bass. So I used to play in orchestras. And yeah, totally non-technical. So if I can do it, you can, as I said before. And feel free to ask questions anytime. Just pop them in the chat, or feel free to come off mute and ask me, because I won't have the chat open while I'm presenting. I'll kind of jump off and check it every now and again though, but Amrita, feel free to interrupt me. I wanted to find out about you all just so I know how much kind of introductory information to give you if you need that for GCP, or if you're already familiar with GCP and you just want the kind of technical side. So would you mind popping in the chat, or you can jump off mute. We'll just take a few minutes. Just letting me know any of these questions you're happy to answer. So have you used GCP before, or another cloud platform like AWS or Azure? Have you worked with websites before? Because we're hosting a website, developers are probably familiar with the concepts, but if you're like a UX designer or a QA tester or something, you might not have kind of dealt with all of the website stuff as much. So I'll just make sure I explain that. What interested you about today's session, so that I can talk about the things that you're interested in. And is there anything you're kind of nervous or worried or confused about? Because hopefully I can clear that up or like reassure you. There's a little bug. So I'm just gonna come out of the sharing to see the chat for a minute. And you can feel free to come off mute if you like as well. I'll just stop sharing for a sec. Oh, I should probably I'll put the questions in the chat as well. How's the weather over in Kuala Lumpur? Hopefully not super hot like ours.
Well, it has been sunny and rainy. So we have someone. So Jinkun has shared yes, yes, and would like to see practical ways. So for the first 3 questions.
Yeah, sorry, I can't paste a comment in. I was going to paste the questions in the chat. I'll just share that tab again so you can see the questions. There we go. I'm jealous of the rain. It's so gross here. So yes, use GCP. Yes, worked with websites. Cool. And practical ways. Cool. To set up and use GCP. Any other information about like any people that haven't used cloud ever before? Which is totally fine.
Yeah, so last month we actually had this a challenge called the GCP Volley Challenge, where we had people from various backgrounds coming in, trying out using Quick Labs, and it was
cool.
like a three weeks event. So they were given our participants were given free credits to explore all these different labs and quests. And I believe that many of our participants today did have like a brief introduction to how Google Cloud and GCP works. So yeah, we have a few more. Yeah, so we have
Nicholas.
sharing.
I love it. I'm with you. I feel like so much in tech, like you think it should be straightforward and then you actually do it and it just is not straightforward. Yeah, that sounds cool. Quick Labs is great. They're really, if you can get your hands on credits, if you keep an eye on like different events and different like Slack groups, you can also find like different places that give free credits, and that can be cool. And these communities are really good for that as well. Yeah, cool. And did people do Quick Labs on just like any subject of their choice, or was it a path for example, like developers or like system admins or something?
Yeah, so our focus this year was mainly for people to learn more on BigQuery and also machine learning, so like more of the MLOps side. So yeah, apart from that, they were free to explore all these different paths that they're interested in as well. So yeah, I believe that we have a very diverse background over here. We have people coming from different career paths as well. So yeah, we pretty much accommodated to all these different individuals with different passion and interest.
Yeah, that's awesome. Okay, I'm just going to stop sharing again and come back to like so I can share the screen rather than the tab.
Okay.
Thanks everyone for those responses. That's great. Do the entire screen. Amrita, if there's any more responses, would you mind just interrupting me and telling me? I can
Sure
see
thing.
Mengun Lee's.
Yeah.
And
Okay, we have another one as well.
Infra. Infra is great. So one of the things that while I was preparing for this talk, that I kind of felt really strongly was I really love platform, cloud, and infrastructure. So I stayed in cloud since I went into DevOps. And doing this tutorial, I was like reminded why I like platform so much. It's kind of, you deal with a lot of things like YAML files where it's just like key value pairs and you're just writing like how many of a server you want or something. And there's a lot of pipelines, which is also just YAMLs. So it's very human readable. It's just like you write a step and then you write what's going to, like what that step will be called and what it will do. And it's really efficient a lot of the time, not always when you have to do workarounds. But I remembered like doing things like the website configuration, how tricky all of the web dev stuff can be, and like really fiddly depending on your device, and a lot of the instructions are kind of out of date or for someone else's like settings or something. So I feel like with infrastructure, you get a different set of problems, but it can be really like satisfying kind of thing. Where with web dev, I get kind of frustrated really easily, and then I feel stupid that I don't understand what I'm doing. And Jim Kuhn worried about handling traffic to website. Oh, wow. 40,000 users. I would love to have that much business going to a website. That's a great problem to have. So thanks for those responses. I'll just make this screen full. I'll make it full screen again. And then, yeah, Amrita, feel free to interrupt me anytime. Thanks, everyone. So why host a static site on GCP? I think it's important with cloud, and you would have seen this if any of you were using the quick labs, to really evaluate like what your needs are and what the kind of results you want at the end of the day are. So in that use case, just in the chat, then 40,000 users and managing traffic, you're not going to do what we're doing today, probably, unless it's a static site, and then maybe. For those who aren't as sure about the difference between a static and a dynamic site, static is when you don't have any interaction from the other side, from the client side. So you would just have your website files, and the kind of, you just are displaying those website files basically. So Google, for example, is a static site. With a dynamic site, it's when you're getting input or interaction from the users. So it means that there has to be kind of something happening server side. For example, any site that you log into, or you're going to want to display content to someone based on the type of user they are, or if you want to have like a form where someone can submit something that's like interacting with the site through the server, that's a dynamic site. So why we would host a static site on GCP in a GCS bucket, it's good. It's a good use case if you have a static site. So that's just pages you want to display, like a landing page or a portfolio where you're talking about yourself, or like a blog where you're just displaying the content, and without private information. The reason for that is that with a GCS bucket, by default, it only hosts on HTTP. So you can be secure with HTTPS, but that's outside of the scope of what we'll cover today. You need to set up, in that case, an SSL certificate and a load balancer, and that can then handle HTTPS. So it's not, it's just some extra steps. It is still relatively cheap compared to other options, depending on the amount of traffic you have. And sorry, I guess the size of your website. And it's comparatively straightforward. The steps are just really at a high level. Like I said before, uploading files and configuring the domain name. So you do need a domain name for any website. That's the URL that people are going to type in to see your content. If you had a different use case, so for example, if you had an application where people were going to be interacting with it, or a dynamic website, you can use something like Firebase. I read a lot of tutorials that Firebase is kind of preferred by a lot of people. It has free hosting by default, and it's a global CDN or content delivery network. A GCS bucket behaves like a CDN by default because it caches the files locally, and it's very cheap. So I think it's about like a dollar, Australian dollars, like $1 to $2 like every year. hosting sites that you pay for are probably going to charge you like the same price that you would pay for a domain name, for example, which might be like $5 up to $25 Australian dollars, usually around the like 15 to kind of 20 mark. So for example, this domain I'm using as a test today was like, I think $18 for a year. So the hosting is free on Firebase. The hosting is also like essentially free on with a GCS bucket, and it's essentially also a CDN. It just kind of, in that case, it's going to depend if it's a static site and you don't care which, it would depend on your preference. So when I was preparing for the tutorial, I did log in to Firebase, set up an account, kind of looked around, and I was like, I can't be bothered like getting my head around this right now. Whereas a bucket for me is really straightforward. And I kind of find the GCP interface quite, it's not like simple. There's a lot of things in it, but I find it a relatively clear experience to navigate around and to search for things. With Firebase, it was like a whole new dashboard. So if you're a bit more advanced and experienced, or your website, so in the use case, I think it was Jun asked about, Firebase might be a better option for your website, or the third option, which is using a virtual machine called an instance on GCP. So another side note with cloud, if you're new to cloud, is that the three main cloud providers, there are others like Oracle and IBM, but Google, Microsoft, and Amazon have the kind of majority of the market. They all have kind of their own terminology, but the same kind of concepts. So it's all just things like computing resources like networks and storage, for example, CPU, memory, but people have found a way to programmatically, so by like coding essentially, or by writing commands, they've found a way to abstract those resources away, and then they can like rent them to you and I. So that's also just something to be aware of when you're looking between cloud providers, or you're trying to decide which one to use. You'll see different terminology, and it's a little bit frustrating, to be honest, but it's of course the way the industry develops. So you'll hear it called, I think, a VM in Microsoft, but in Google it's an instance. And in AWS, I think it's a compute instance. I can't even remember, EC2 instance. So instance and a load balancer is for kind of heavier traffic or dynamic sites. And then there are also other options. Any others you've tried, feel free to pop in the chat if you've got some advice or some experience around like what worked well for you and what didn't. Rita, there's no questions about that so far, are there? Or would anyone like to come off mute and ask a question?
We do have a question. So Mangon is asking, what's the difference between static and dynamic sites?
Yep. So as I said before, a static site is where you're just displaying pages. So someone's going to type in your URL, and then the server is just going to be like, here's the page. And there's not going to be anything that you have to interact with as a person viewing that website. If you're going to either log in or like type something into, for example, a form and press submit, so like send information as a user, that's a dynamic site. So static is like no interaction from other people. Dynamic is interaction from the person looking at the website. Even if they're not interacting with it, you've got that functionality built into your website. Let me know if there's another question if that's not clear, and I'll answer that too. So there's no stupid questions. All questions are super welcome. So I'll keep going and just, pop questions in chat or come off mute anytime.
Yeah. So yeah, I'll bring it up when we have another question. So for now, this is about it.
Awesome, thank you. So things you'll need for today, and things we need just to host a static site anywhere really, not just on a GCS bucket, but to have a website, you need a domain name. So I'll show you where you can look for that. It's just something that you buy for usually a year or 2 years, and it's the URL that someone's going to type in to see your site. And for GCS bucket, we need the kind of parent level, the top level, so not a subdomain. You'll need your credit card information, although you're not necessarily going to have to pay a lot or anything at the moment, except for a domain name you do need to pay usually. I'll talk more about that on the next step, but there are free options, but I don't think any of them work very well. But if you're going to have your own website, it is something that's worth spending the money on if you can get the money, because you'll use it forever potentially. So credit card information or PayPal, and you need those two for a domain name, and also because you need Google billing enabled for GCP. A small budget for the hosting, like probably about $1 to $2 a year. With more traffic, like with 40,000 visitors a year, it's probably going to be more than that. And depending on whether it's a static or a dynamic site. So for example, using like Google App Engine or something to host things was more a more expensive pricing model, but it's more appropriate for heavy traffic. And then the last thing is your website files. So if anyone has questions around the website, pop those in the chat too. You don't need to have one. I'll show you a site where you can download a template if you don't have them just handy. The minimum you would want is probably an index.html. So that's just your whatever you're going to use as your homepage or your landing page when someone types in the URL. It's good practice to have a 404 page. So that might be like 404.html or 404-error.html. And you'll probably have a styles.css file for all of your styling. That's what you need for now. And if you don't have a domain name, we'll talk about that in a little bit, but you might want to get one and then come back later. It kind of depends on whether you have the budget or the time to do that now. So if you don't have them, totally okay. You can do it instantly with Google domains. Other domain providers, it will take longer than, it'll take like 24 up to kind of 48 or 72 hours to have that information sent out across the internet. So yeah, you wouldn't be able to finish it right now kind of thing. With Google domains, you can. Even though I'm a GDE, like a Google developer expert, I'm not pushing necessarily Google products. That was just my experience when doing the tutorial. So feel free to share your experience if you have different products that have worked really quickly or anything as well. Was the process easy for me when I was preparing for this talk? No. So I kept getting this verification failure when I was trying to set up the website. It was so frustrating. I was up at 2 a.m. trying to get it to work. And I was just like, why is this so hard? All of the tutorials are just it works straight away. And I forgot that with DNS, it can take time for the records to work. So I kept refreshing every kind of 20 minutes and it still didn't work. That's why eventually, so I bought domains with Namecheap and with GoDaddy, and I already had one for my website, but I ended up just buying a new one with Google domains, and then that was instant verification. So that's why today, if you don't already have your own domain name, or if you can't get the verification working, then if you have the budget, I recommend just buying a domain on Google Domains if you can find the domain that you want. Any questions about a domain namey thing so far? Just yell out if there are. So I'll go through, this is an overview of the process. Feel free to pop questions in the chat again. I'll give you some links at the end of this. If you're a bit more advanced and you would like to just look at a tutorial, go through and have this on in the background to come and ask questions if you need to, that's fine as well. Go ahead and do that. To host a static site, so we'll go through this at a high level, and then I'll go through with more detail, and then I'll do a demo at the end. So you do need to own your domain. If you have a subdomain or you're not the owner, it won't work in terms of setting up, configuring the GCS bucket. So you need to own your own domain. You can buy now, but it takes time to verify, with the exception of Google domains, where it will be instant verification because it's within GCP. You need to create or have a project in GCP with billing enabled. If you were doing Quick Labs and then you were trying to do any of that yourself, if you had the credits, you might already have a project, so you can just add it to that project, or you can create a new project. There's no charge for doing that. You'll just get charged on like how much I think happens with the storage, and it won't be very much. You'll need to create or have website pages. So I'll show you a place you can download a template if you don't have time or you don't have your website files handy. The next step is we create a CNAME record for your domain, and we basically point, so it's your canonical name. It's a way that you're setting up the configuration between your domain name and then the computer readable like IP address. So you're basically setting up that connection so that the GCS bucket and like the internet knows when they hit the Google API that the bucket is where they're going to be getting the website files from. You'll create a GCS bucket, and there's just a few settings with those that you set up. Upload the files for your website. That's you'll be familiar with that step. It's just like drag and drop or clicking like new file and upload. You need to set viewing permissions for the bucket, because with storage buckets in Google, the default is that things are private. So as we said before, because it's HTTP, you don't want any personally identifiable information like names or, someone else's names. Like if it's your portfolio, you'll have your name. But you don't want any private information, so just make sure you don't have any of that. By default, buckets are private. So what we'll be doing is just setting up what's called a role, or like basically permissions, to say that we're going to authorize the public or anyone, and that's called all users in GCP. We're going to give them the permission to see the files in our bucket, and that's what will make your website visible. If you don't set those viewing permissions, people will just see like an error message when they go to your website, even though the files are there. The last step before we test that everything's working is you configure your homepage. So you have the option to, in your bucket files, set up what the index.html is and what the error page is. So I'll start going through those in more detail now, and just, again, pop in questions anytime. I was going to pop this in the chat too. So if you do want to jump ahead, I looked at a lot of different tutorials and videos for you to kind of pass on the best resources. I'm a really literal person, so I need like detailed instructions with images, basically. So I found a few different video tutorials, but they were a bit out of date or they weren't like detailed enough. These were the two resources I think are the easiest to follow along. So the first is just the GCP like instructions for hosting a static website. When you see storage, that's what the buckets fall under. And the bottom link is Code Labs. If you haven't seen Code Labs before, they're just a kind of uniform way that Google has developed, or sorry, GCP has developed to display tutorials. So they kind of render really cleanly, and they're just technical tutorials on lots of different topics. Someone's done one on what we're looking at today, and I found that one probably the clearest to follow, and it's up to date. So if you want to just go along by yourself or have that open, have a second resource to refer to, that is an option for you. So I'll just grab those links and pop them in the, I can't put them in the chat. You will have to take a screenshot and type it in yourself, like old school. Or Marissa, if you can, you have access to the slides, if you could copy the link, and I don't know if you can post comments in the chat.
I'll be posting it right now, yeah.
Thank you. Oh, you can, yeah, I saw your messages. So the first thing we'll look at is, for those of you who do own your own domain already, or like if you're like me, you had one that you bought years ago and you kind of are like, is it still registered? The way that you can look at that is in something called the Google Search Console. And that's how we can also verify our website. So remember the verification failure message before that I got 10 million times? This was my final result, the green auto-verified, when I bought the domain off Google Domains. The site is search.google.com, and you post your address, your URL, in the domain. So you don't need HTTP or HTTPS in front, just the domain part. So it might have www, or it probably will if it's a parent. It might have something slightly different. And you'll click continue and get it verified. On the right-hand side, you can also test, but I think if you can use the left-hand side, that's, I think, easier to do. They have instructions for how to do verification for different websites as well, like with Namecheap or GoDaddy or whatever kind of different domain, like places that you bought a domain from. So if you need to buy a domain, we can do that. Just go to, for Google domains, it's just domains.google.com. You'll then search like whatever you want to look at. And if you're not sure, you can just do like domain name, like buy or whatever, look at the different websites. There are free domains, but I couldn't get them working easily. And it is something I think you have to pay for a quality domain name, unfortunately, or fortunately. It's probably a good thing. So if we do like Google domains, you'll just search for like whatever you want. So I was just doing like KL Cloud, for example. I went with KL Cloud Demo. This is the Google domain site. So just get a new domain. So you search whatever words you want and it will show you all of the options. So most of them are around like $15 to kind of $30 in Australian dollars. And then you'll just like click add to cart if you want to buy one of those. Again, you can buy it from wherever you like. So if any of you have good domain name like sites that you've used before that are reliable and cheaper, I think they're usually all around that cost, but please pop them in the chat so people can have a look as well. So the next step when we've got a domain, if you need to buy a domain, feel free to go do that now. If you need to do it from a site other than Google Domains, you'll come back and do the rest of the tutorial later. If you do it with Google Domains, you'll be able to keep going instantly with the verification. Just a reminder. So next thing is having a project in GCP with billing enabled. So when you go into GCP, so console.cloud.google.com, I might go through the steps and then do the demo at the end. But if you prefer to see me like type everything in and go through, put that in the chat and I can do that. I don't have a strong preference. And I'll just add a note as well. I became a Google developer expert just quite recently in GCP, but I've only been using GCP for like, it's not even 2 years. So they brought me into the program. And if you would like to know about GDE, it's a cool program as well. Let me know and I can talk about that. It's basically a network of like speakers and technologists who are sharing information with the developer ecosystem around Google services or products. They wanted the perspective of someone who is new to the industry because there's one of the things I kind of talked about in the interview process is I think that there's a really big gap at the moment between the public and also developers sometimes, and then the world of kind of cloud. We need to kind of increase the amount of people working in cloud because it's only going to be increasing more and more in terms of the, how many like websites and applications it encompasses. And I think there's a gap in terms of literacy with the public and with general people around those concepts. So we have this situation at the moment in the world with people making decisions in businesses or just in your personal life about how you're going to be doing some kind of technological solution. And often in businesses, the people making these decisions about cloud and wanting to use cloud native design, for example, they don't really understand like the concepts of cloud. So people think you can maybe just do what's called a lift and shift and move things from like on-premise into the cloud, and it can be the same architecture. Cloud native is totally different. We often talk about having like a microservices architecture where all of the different functions of an application are done separately, like probably with different tooling potentially. So that every concept in cloud is quite different, although of course it's got its origins in the physical world. But yeah, I really encourage you, if you haven't used it much more, to keep going. As someone said before, it can be really confusing to get through. I'm not even going to say at the start, like, it's confusing to me. A lot of the instructions, and I think this is across technology, a lot of the instructions aren't clear. A lot of the tutorials aren't clear. People always say read the docs, but the docs aren't very well written a lot of the time. Google tend to be one of, I think, one of the better places in tech in terms of their documentation. They have very well documented products and tutorials. So that's something I also really like about Google. Coming from AWS, where different teams are allowed to kind of do everything themselves for their product, and then you get all this kind of different standard and different quality of the information. I found that extremely frustrating. So yeah, cloud does have a lot of products and services because of the way that the architecture works in the cloud, and because we have this concept now of microservices architecture, and they're all trying to be the kind of one-stop shop to make it easier for customers. But yeah, stick with it. It's totally learnable. It's something that you can do if you're interested. So in terms of creating a new project, just console.cloud.google.com. You'll see your little avatar in the top right, and you'll see your projects in the middle if you have any already existing. And if you don't, you'll just be on the dashboard, and you'll be able to see a button to choose new project, and you can just type in a unique name. You do need billing enabled. It might be already if you set some things up before. If not, just go to billing. So in everything in GCP, you go to this top left, that hamburger menu, drop that down, select billing. It's usually near the top, and you'll be able to see status active if you have billing enabled already on a project you have. And if you're setting up a project, you might give your credit card. It's not going to charge you, but it's going to be there for the billing later. So our next step, create or have already website pages. So for anyone not clear about what that might look like, this was from the place that I just downloaded a template from. So you can just download something that's already styled for you, and then you just change the words. This site, html5up.net, has really great templates that look quite clean, and you just can edit them to display your website how you like. So if you don't have an app or a website handy just in your downloads or on your local computer, I recommend just going to that site, choosing any template and just downloading it, ready to upload into your GCS bucket. On the left is an example of one that I downloaded. I've downloaded a bunch from there over the years, for different projects. So this one's got a bit more files. What we really just need is that index.html and then some kind of CSS, maybe some JavaScript. But they're kind of fancy, so you can find whatever you like there, and you don't even need to edit it. We can just upload it. So I've just uploaded the template in the demo. Rita, are there any questions so far?
Not at the moment.
Awesome. And please tell me if I'm talking too fast or anything as well. I tend to talk fast.
No worries. The
Try
pace
and rein
is
it
good.
in. So as I showed you briefly before, in Google Domains, I bought that domain just as a test for today. So klclouddemo.xyz. What we'll be doing is creating our CNAME record. And that's basically so that we can have a URL that we've bought that is kind of human readable, and then we can kind of translate it so that the computer or the server can also find the equivalent IP address and then use that. So what you just do in Google Domains or in your domain name provider is you'll go to DNS. It might be in advanced DNS. So for example, in Namecheap, I think it was in DNS and then advanced DNS. and you're looking for the part that says something about records, or it might give you options to have like a TXT, a text record, or a CNAME record. There's different types of records. So look for wherever they have that kind of thing. They also might have something like custom name servers or name server. It's called different things in all of the different places. We're going to create a CNAME record, and that means you just put your website. You can choose, like, this is kind of, I just left this in an hour. You can choose a different time. It's just the time it'll like time out. And then you need to copy c.storage.googleapis.com. And that's the only configuration you need to do for a GCS bucket. So it's that one record, and that will handle all of the configuration for your website. Then we can create our GCS bucket. So in Google Cloud Platform, buckets are a type of storage. So when you go into your hamburger menu, you'll click down and look for cloud storage. So it's about like a third of the way down. And we just go to that first tab called browser, and that's where you can create a bucket. It's not going to charge you anything again at this point. You'll get like billing at the end of different periods. And you can set billing alerts if you're worried about the cost, but it really shouldn't cost you much, if anything, with a GCS bucket. This was an example of my many failed attempts. I had She Writes Like a Dream as a domain I already owned. So we'll give the bucket the same name as our domain name. So for example, I, in the second one, used the domain that I bought. So you give your bucket a name, and then there's a few different steps. So with the region, you can go multi-region for, So for example, if you're going to have traffic across the world, or a lot of traffic, multi-region is probably the best. Oh, not best, sorry, the most appropriate for that use case. If you're probably just making your own portfolio and you expect it to be people just in your region, you would just choose region. That's going to be slightly cheaper, but all of those options are relatively cheap when we're talking about a GCS bucket. Choose your location. It doesn't have to be where you are. You can have like US East 1 or whatever. You'll choose a storage class. So the default is standard. If it's just a website where people are going to be kind of looking at it, standard is probably the best option. And storage size, I just went with like a gigabyte. You can have a little bit more. You can start off with a small amount and then test how it's performing. And the operations you can just leave empty. What we do then is just upload the files. I literally just like drag and dropped mine. You do need to do folders and files separately. So you can see upload folder here. There's also upload file. So do upload file and then like shift or whatever your button is to highlight multiple and then put them all in, or highlight them all, then drag them in and then do folders separately. Once all your files are in there, this was from another of my examples. You need to go, so you can see the default tab that we're on in the GCS bucket is objects. So anything we're uploading into the bucket is called an object in GCP, whether that's like an image or a file or something else like a text file. If you go to permissions, that's the place where you can set up roles or like users or how you want people to have permission. So you can see before I set this up, it says public access, not public. So that's that default setting. So when we go to permissions, you'll see you have the option to add, and you can choose principals or roles. Principals is just like the type of user. So when we're talking about public access, we want to use all users. So it's written as one word with a capital U, all users. That's just something you can remember for public. Then we're going to assign them just this one option, storage object viewer. that's what's going to then make them be able to see the files. Otherwise, they'll get that error message. So you'll go to cloud storage, same as when we looked for the buckets before, and then storage object viewer and select that option. And then when you've selected it, you'll see if it's worked. You'll see that you'll get this little warning message that you've granted access to everyone on the internet and you're letting them see all of your files. And that's what we want, because we want people to see our website files. We don't want them to see an error message. But just a reminder, it is on HTTP and you don't want any personal information in there. So nothing you'd like, no information that you wouldn't be comfortable with on the internet. So I just kept that message there to show you what you'll see if you've got something wrong with your configuration or if you haven't done the configuration yet. So you'll see some kind of error message like that there isn't like information displaying by the server. So basically we haven't told the server which file to display and it doesn't know what to return to the person typing in the URL. So there's one more step to fix that. So when we're in our bucket, this is, I'll just click back. This is that same screen here. So you're just in your kind of bucket screen. If you go right over to the right and you'll potentially need to scroll across, you'll see 3 little dots, and that's a drop-down menu where you can click to edit the website configuration. And this is where we can tell the bucket which file we want to associate with like which parts of the website. So you'll see the main page is probably going to be index.html. If you're using any of those templates from HTML5 up, it will be index.html. Most free templates will be the same. And you can also just create your own index.html locally and upload that if you like. If you have a different name for your homepage, like homepage.html or something, you just put that instead. And with your error page, same thing, you'll type in, I had that as an extension that we could do, so I didn't do that here, but you'll probably have something like 404.html. And it'll just be a page saying, this page doesn't exist, or the page, something's broken, like we're sorry. And then you should be able to type in your address. This was the template I had from HTML5 up, and it will then stop displaying the error message because it knows which file to display, and it will display your web page, and then you can celebrate at 2 a.m. like me. So if you've been following along and you've done that already, or if you want to follow along next steps later, if you're going to do this as like your own project in your own time, the things you would then do is if you're using a template, obviously you would edit them all to be the content that you want to display. And you would also just be deleting any of the files you don't want to use, and you just upload them. So one of the things with buckets is they won't have duplicates. So you just upload the new version and it automatically replaces anything with the same name. You can add an error page and upload that, and then go to the website configuration and configure it. You can set up HTTPS, so that needs a load balancer and an SSL certificate, like I said before, because the bucket by default just does HTTP. If you want the kind of free hosting and the global CDN, and then something that's kind of a platform already set up for websites, you can also try doing all of this on Firebase. But that's it. So I'll just stop and then do that as a demo relatively 3:15, 11:45, I think for you. No, 12:15. I'm terrible with time differences. So we'll see how much time we have for a demo, because I'm also aware you've got a pretty full-on day. So if you want to drop off and have a 15-minute break before the next session, that's fine too. But have we got any questions at this point? I'm going to jump out again and stop sharing for a moment. Can't see anything there now. So I'll just, I think I'll start sharing the tab, and I'll just show you through like how I set things up. So the benefit to have the load balancer is to kind of handle your traffic. So if you do have a lot of traffic or you want a kind of server to manage that for you, not a server, sorry, a service, that's when you would use it. If you just have like a static site with, even with a lot of traffic, if it's just static, you don't need a load balancer unless you're going to do the bucket and you want HTTPS, which is recommended. Then you would set up the load balancer and it's just going to be handling HTTPS, basically, like HTTPS requests. Like I said at the start, though, it always depends on your use case. So it always depends on why you are doing something, or like if you have a customer you're doing something for, what they need in terms of like their budget or their time or what skill set they have like around them and what people are familiar with. So it just kind of depends on what you're trying to achieve as to like what would be best. And there's sometimes multiple answers as well. Rita, would you like me to keep going and just show through like the interface and a little demo, or would you like, because there's about 13 minutes left, do you want me to stop here so people have a break?
Yeah, we can go ahead with the demo, but before that, we do have a question from Mang-un. He's asking what's the benefit. So yeah, you have like gone through it. So I was expecting that, probably a bit more explanation on that.
Yeah, no worries. So basically, with a static website, it's probably not as relevant because you're just showing one page, right? And even if you're going to get a lot of traffic with something like a bucket, it's going to cache the files locally, so it's acting as a CDN. When it's going to be a benefit is when you're wanting to kind of prevent overloading like a resource. So if you're getting too much traffic, like we had the example before with like 40,000 people trying to hit a site all at once, that's when a load balancer can be useful because it will kind of distribute traffic it's like when you have a queue and you have people kind of directing you to what the fastest like way in is. That's what a load balancer is doing. Do you need, like, is there more specific information you want to know about a load balancer?
I think for now this is good.
Yeah,
Mango,
cool.
and if you have more questions, feel free to just put in the chat. But yeah, I guess we could move on to our demo.
Yeah, cool. So one thing as well, sorry, just to be aware of with like a load balancer is also to think about like performance. So it can improve performance basically of a website or of a resources. But when we're talking about a static website, it's like a little bit different. If you're imagining like an application where people are interacting with things and there are like requests, from my understanding, but my understanding is like limited. Yeah, that's when it would be like useful. So also how to set up firewall rules for static sites. So we're not, that's not in the scope of today because we're just going to be setting, like the easiest way to host a static site in this way is to not have, like you don't need firewall rules because you're not using something like a VPC, a virtual private cloud. So when you have like a private cloud or something that requires firewall rules, that's when you're going to have to set up like rules to allow ingress and egress. So you would be talking about, depending on whether you have your code stored, like whether you're using an infrastructure as code language like Terraform or something, you might have a file for all of your firewall rules, and you would basically list like the IP addresses that you want to trust, and then you would be using Terraform to serve like the GCP resources, and it would handle all of that for you, like that configuration. If you're doing it yourself, you would be doing the same thing, but in like the GCP console or from your command line. And you would just basically be adding like a list of IP addresses that are trusted, and that they would be the only ones that would be allowed ingress or like entry to view those files, like entry into the cloud essentially. And if you were on a website, sorry, on a like a device that was trying to see those files, and you weren't in the firewall rule, then you wouldn't be able to see. But yeah, for today, that's not in scope because we can just make the files publicly accessible, and that's appropriate in the use case of this static site. If you were wanting to do that with like an application or a dynamic website, I think probably Firebase would be better because it was built for like hosting applications and it's got the free hosting. So hosting can be like another cost on top of buying a domain. And that's why the options like Firebase and GCS Bucket are good ones, because it's really cheap, comparatively cheap or free in the case of Firebase. Cool. So thanks for all the questions. That's great. It's great that you're like thinking about those things as well. So if we go from the start, so I am going to say that I already have the domain. So I just basically went in here and then, like I said, put the domain name in the cart. Let's say I have my domain. I need to verify I have it. I think I had to remove www maybe here. Maybe not. I had to do this like a few times still because I like the instructions. I'm always like, why aren't they clear? So you can see it will kind of not work until you've got the domain. You'll see auto verified, or you'll get the error message. If it's a domain that you've just bought, you just need to wait some time, or you might need to check of how you've verified it. If you bought it in domains, you'll see this straight away, which to me was kind of worth it, to be honest. So once we're in here and we've done our verification, we're going to jump out of Google search. We don't need to use that anymore. And we're going to be, let me just check I'll do it in the order that I did here. So we're going to create our GCP product. So console.cloud.google.com. I always forget that and type it the wrong way around and think that Google's gone down. So it'll auto log in if you've got it set up like that, and you'll see your little avatar, or you'll be able to use like single sign-on usually. Pretty much everyone has like a Gmail account these days. So you should be able to set that up relatively easily. So if you don't have a project, I already had one. I just had one sitting there from some, like, I have no idea what it was from some like probably a similar activity to your one on cloud, where I just done it as a practice. So you just click new project. You can have a name, so like website demo. You can change this later. I do think you need to, do you need one? I'm going to put no organization. So I think that I've got that organization there from GDE. This was all my failed tutorials. You're welcome. You didn't have to see that drama. So you can just select the project once you've created it. That will be instant, the creation. Or you can always come back to this tab up here and click through. If you're not seeing what you expect in the dashboard, it's usually because you've come into either a different organization or a different project. So just remember with GCP to check that. It's also something to check on the other cloud providers. So once we're in our project, what was the other step? We're going to get our website files as well. Make sure we've got those. I've got a bunch of these already downloaded, but I'll just show you. So you can see all these different kind of templates. Let's say we just like this one. It downloads it straight away. You do need to unzip this before you upload it. So I'm just going to click into that so that I can just drag and drop them when I'm ready to. And then now that I've got my website files and I've also got my billing enabled, oh, sorry, we didn't check the billing. So I'll just show you how to check that too. So if you click on GCP all the time, it just takes you back to that dashboard. To get into billing in the top right, it will be that second one there. if you want to pin something so it's at the top here, like I've pinned cloud storage just so it's handy for today, you just click on that pin and it'll bring it up the top for you, so you don't have to click through all of these different options. You can just do that with billing so it's handy as well. So in billing, we just want to make sure that we've got billing enabled. So if you see like a billing account, you've got billing enabled, and that's okay. You can also check that in your project if you like. So I'm just going to go now into create a bucket. So cloud storage, browser. Cloud storage, again, bucket is a storage solution, a GCS bucket or a Google Cloud Storage bucket. One thing to remember as well, I think I mentioned it before, is that terminology may change. So it's called a GCS bucket today or a GS bucket. It might be called something different in a couple of years because most cloud providers will change the products or the names as technology is kind of changing as well as the need is changing. So yeah, just be aware you're kind of going to see different terminology. So for example, G Suite, which was the equivalent of like Microsoft Office when there was like Gmail and Google Drive, that's now called Workspaces, for example. So we can see here our different domains. So you're going to create a bucket, and this will be your like domain name.com or whatever your suffix is, and you need the dots in between. I don't think they have to be unique, so I might not. I'll just do this to show you the settings, but because I've already used the domain I bought, I won't kind of set that up. So choose your name, continue, multi-region if you're going to have a lot of traffic across the world, dual if it's two specifically, or just like your closest region. So obviously I'm in Melbourne and we have our new Google like Melbourne region, which is cool. So default storage class is, just make this slightly bigger actually. So standard is probably what it's almost always going to be for a website because people might be accessing it. For kind of applications where you might not be accessing the data as much. So for example, if it's in your workplace and they just want to be accessing things like once every few months or something, or like not super often, that's when you would choose something like Nearline. Coldline is for DR, disaster recovery. So when you need to access the information, but you're not expecting it to be frequent and you don't need it to be kind of instant. And then archive for just archiving data. So that would be, for example, where I work at a bank, they have to keep things for a certain number of years for audit purposes. So that's what you would use for something like that. For most of us as individuals, it's always going to be standard. Continue through. You can choose here uniform or fine-grained. And if you look at tutorials, you might see these called something different as well. They've had different names over the years. Basically, fine-grained allows you to actually specify different objects. So that's probably more appropriate when you're going to have like a dynamic site where you're having people log in and you want to display to them like certain things, or when like you want someone to access like the files that are associated with their name and not someone else's or something. We don't need that for a static site. So just uniform. And then storage and retrieval, so whatever your size is. You don't need to put operations. That's just like retrieving the website, basically. And you can see that it's estimating it's going to cost like 23 cents. If we do like 1 gigabyte, it's 2 cents. So it's almost free. And then you'll create that bucket. You can see I don't have the domain name. So it's going to throw an error message if you don't have your domain name or you're not the, the registered owner. So if you see that error message, you're going to need to make sure you own the domain name or it gets transferred into your name. So let's say that we've created that bucket and then I would have seen this. I'm then going to upload my files. So I might just, delete all of these and then re-upload. So with most cloud resources, if you're deleting something, you'll need to type like the name of the resource or delete just to be sure that you haven't like made a mistake. So I'll show you as well with this domain, we can copy it quite easily. If I go here now, we're going to get that error message because we deleted our files. I can see it's 3:30, but your time 12:30. So I'll just show you from there. You would upload the files and then upload that template. And remember, you do the files and the folder separately or literally drag them in. And you would then at the end here, oh, there's no files. So you'll see the 3 dots here and you'll have to scroll across. You would click edit website configuration, type in index.html, and then this would display that site. So those are just those last steps. And I'll stop sharing now and say thank you very much for having me. And I hope your rain clears up if you don't like rain. And enjoy the rest of your day.
Thanks a lot, Gwenny. I mean, I love this session. I love how, it's so hands-on. And, it's amazing how you didn't just talk about the technical aspect of it, but also shared about your personal experience, which I think that would be very inspiring to many of our participants here. So thanks a lot for joining us today and for spending your day with us. And I hope we would have you joining us in future events as well.
Hopefully in person one day.
Absolutely. We'd love to have you here one day. Hopefully when things get better and, traveling restrictions aren't there anymore, we'd love to have you here. So once again, thank you. Before we end today's session, do you have anything like, to say to the to our participants today before we move along to our next session?
Yeah, just in the introductory video, I really agreed. It's really important, these community activities that you do, and they can give you opportunities you haven't given before. They give you stuff to talk about in interviews if you're applying for jobs. They really enrich your life. So I honor you for turning up in your free time. I know it can be tiring to do that. So well done to you all for having that interest and like following your interest and being curious. It's also can be quite scary to do that if you're new. So well done for coming along, especially the students. That's really great to see. It's always great to have students and know that they're participating because it's pretty hard studying all the time. So I know you don't always have a lot of energy. So just well done to all of you for being here. And let me know if you put your sites up. Show me little screenshots.
Absolutely. I'm sure that everyone would be thrilled to share with it, share it with you. And once again, just a quick reminder to everyone, we have shared Gwenny's LinkedIn profile in the chat. So feel free to reach out to Gwenny. Feel free to connect with her. So thanks again, Gwenny. And we'll see you soon. All right. Okay. So now we'll be moving on to our next session. And so let me briefly introduce our speaker. So today we'll be having Anandan. He's a third year PhD student in the bioengineering department at UIUC. He received his bachelor's degree in computer science at Reed College. It's a liberal arts college in Portland, Oregon. At this time and point, his main academic interests are machine learning, complex networks, and scientific computing. He is especially interested in biological applications of mathematics and computer science. He also participates in projects that involve computational modeling in general. So let's get Anandan to join us today. So, okay. So, hi, Anandan. Thanks for joining us today. I guess we can get started with your session. But before that, do you mind sharing with us what you're going to talk about? And just a quick introduction of today's lightning talk.
Yeah, so the idea is What if we looked at biology as a language, and how we can adapt tools that people have spent a lot of time developing from natural language processing, but apply those to biology?
All right, cool. Yeah, so do you mind sharing your screen and we can get started with today's session? So we did receive quite a number of requests from our participants asking for more talks on, AI and yeah. So to you enthusiasts out there, we hope you would have a great time. So the stage is all yours.
Okay. Yeah, so again, I'm Anandan. I'm a graduate research assistant and PhD student at UIUC, where I work on mostly biological applications of machine learning and computer science. Yeah, so today I'm going to give a talk that I like to call Transforming the Language of Life, where we look at transformer neural networks for protein prediction tasks. And most of the content from in this talk is from this paper that we published about a year ago with the same name, Transforming the Language of Life, Transformer Neural Networks for Protein Prediction Tasks. And it was at the ACM BCB conference last year. Okay, so a little bit of biological background that should probably take like a minute or so. By language of life, we mean proteins. And proteins are really important in biology because it's what drives most biological functions. Enzymes are made of proteins, hormones are made of proteins. So they're really important for life to happen. And proteins are made up of amino acids. There are 20 different amino acids. And these amino acids form initially a primary structure, which is essentially just a sequence of amino acids, which can then fold to create these more complex structures. But to start with, they're just a chain of amino acids. And yeah, these chains of amino acids fold into secondary structures, tertiary structures, and these tertiary structures can bind to each other to form quaternary structures as well. Yeah. So we start with the primary structure, which is just a sequence of amino acids. And since there are about 20 amino acids and 25 English alphabets, you can sort of match every amino acid to an English alphabet. And now when you look at the primary sequence of a protein and you squint at it really hard, it kind of looks like an English sentence. And our goal is to take that sequence of amino acids or primary structure of a protein and get a vector representation for it in some high dimensional space where n is the dimension of the space. And hopefully this high dimensional representation of the sequence encodes some biological information about the three-dimensional structure of the protein. So it encodes more than just the sequence, it encodes the biological function or the three-dimensional structure of the protein. And the reason why we want to use embeddings that are inspired by natural language processing is because these tools are really good at capturing meaning in sequences. So in the NLP context, if you have a sequence called a sequence for the cat is brown, the vector representation for that, which we have as an arrow here in three-dimensional space, will probably be closer to the vector representation for the pup is black then either of those is for the vector representation of the sentence, my name is Bob. So you have these 3 arrows here representing 3 different vectors for 3 different sentences. And you kind of see that the distance between the first 2 vectors is a lot smaller than the distance between those 2 vectors and the one. And this is an oversimplification because typically we embed sequences in really high dimensional spaces. So usually hundreds of dimensions or up to 1,000 dimensions usually. And also in this case, the dimensions are linear. Oftentimes you don't have linear dimensions either. But yeah, this is the basic idea. So one issue with using tools from natural language processing is, unlike English sentences, we don't really have a straightforward definition of a word, because you just have sequences of amino acids which look like this. You don't have well-defined words because you don't have spaces like you do in English. So we use an algorithm that was developed a while ago called biparent coding, which essentially just looks at a lot of these sequences and extracts statistical information about which alphabets co-occur next to each other frequently. So for example, if you find that V and L occur next to each other really often, what you do is you group them together, and now V and L becomes one word or token, and you repeat that until you are satisfied with the number of tokens that you have in your dictionary. So yeah, you use biparent coding, split your amino acids into words, and now you have tokens that are well defined. So yeah. And once you have that, you can use neural networks that were initially developed for natural language processing, but adapt them for protein language processing. In this case, we started out with the BERT architecture, which is a bidirectional transformer neural network that was initially developed for natural language understanding. And in particular, we used the robustly optimized BERT model, which is Roberta, and we adapted that for proteins. And pre-training a transformer using the Proberta model in this case means you start with your protein, which you have split up into tokens, and you hide some of these tokens. In this case, this PG token is replaced with a mask token. And the task for the neural network is to encode all of these tokens into vector representations, and then use the vector representations to try to predict what the hidden or mask token is. So in this case, you're hiding this token, and then the neural network has to predict that this mask token is this PG token. And it does this because of the way transformers work, by paying attention to all the other tokens surrounding it, which it uses as context. And that's through the attention mechanism in the neural network. And the hope is, because the neural network has to pay attention to all of the surrounding tokens to predict what the hidden token is, it will extract some biological information about what token is most biologically feasible. And that will encode some biologically relevant information. And so we trained our Proberta model on a few 100,000 sequences, pre-trained them. So at this point, the model has not received any biologically relevant information, right? So it's just looking at the sequence, hiding some tokens, and then trying to predict those. no biological information has been fed so far. But when we looked at these different protein families and we plotted some of the proteins from those families, we took the vector representations, reduced the dimensions, and then plotted them. We found that most of the proteins from the same family tend to cluster together, even if the model has not been given any biological information so far, which was kind of amazing. And it also supports the idea that to predict what token was hidden, the model has been forced to learn some biologically relevant information. So over here you see the points colored by protein family, which you can sort of think as the protein function. And you see that proteins of the same family are always clustered together, which was a really cool find. But we want to do more with that. We want to do specific supervised tasks with this neural network. So what we can do is once we've pre-trained the model, we can chop off this later classification layer here, and we can replace that with a classification layer for specific tasks that we want to predict. So for example, we can predict protein families directly. Like you already saw that the embeddings do contain information about protein families, but what if we want to directly predict protein families? And that's what we tried to do. And it turns out that Proberta does really close to DeepFam, which was the state-of-the-art method when we tested this. It doesn't quite beat DeepFam at this. So Proberta had an accuracy of 92%. DeepFam had a 95% accuracy. And when we compared it to a simple convolutional neural network, we got 72% accuracy. And although Proberta doesn't beat DeepFam, it's important to note that we built Proberta with the intention of having a generalizable neural network that we can use for different, all sorts of different protein prediction tasks. So while DeepFam, on the other hand, is built specifically for protein family prediction. So in order to test that generalizability aspect of Proberta, we also ran Proberta on a different prediction, in this case, protein-protein interactions. So the idea is you have, say you have two different proteins. These proteins don't function separately. They usually bind to each other or some other protein, and they work together as opposed to individual primary structures functioning separately. And so what we're trying to do now is we're trying to predict if given two proteins, Proberta can predict if or not those two proteins actually bind to each other. And to do that, we found a data set called HIPPY, which is a list of protein-protein interactions that have been shown, list of pairs of proteins that have been shown to interact with each other. And to evaluate this, we also had to create a negative set. So we have examples of proteins that do bind to each other. To generate the negative set of proteins that don't bind to each other, we just randomly sampled human proteins. And if we didn't see that they were in the HIPPY data set, we assumed that they didn't bind to each other. And so we compared Proberta to the current state-of-the-art method, which is Piper. So Piper has an area under the ROC of 0.87, and Proberta was surprisingly really, it was surprisingly better than Piper with an area under the ROC of 0.99. But we also wanted to test Proberta on a slightly more difficult task. So now, when we were generating the negative data set, instead of just picking 2 random human proteins and checking to see if they were in the hippie interaction data set, we chose 2 human proteins that were in the hippie data set, but did not interact with each other. So these are proteins that like to interact with other proteins, but just not with each other. And when we tried to predict using this data set, Piper did slightly worse than it did initially, which is expected because this is a harder task. And Proberta ended up doing a lot worse than it did with the first data set, but it still did a lot better than Piper, which used to be the state of the art. So we saw at this point that Proberta not only matches up with a lot of state of the art methods, sometimes it does beat state of the art methods when we're applying it to protein prediction tasks, which was really cool because, again, Proberta is meant to be a generalizable neural network for any sort of different protein prediction task that you can think of. Next, we want to look at how information was stored in the Proberta neural network. So to do that, we clustered our vector embeddings of proteins, and we tried to compare those vector embeddings with known protein families. So the idea was if the vectors stored a lot of information about protein families, we'd see a lot of clusters, a lot of proteins in the same cluster being from the same family, which you see here. Cluster 3417 seem to have most of the proteins in that cluster seem to come from the G-coupled receptor 1 family. Yeah. So one way of encoding this numerically is to calculate normalized mutual information, which is just another way of measuring how similar the information stored in the clusters are compared to protein families. In this case, we measured normalized mutual information between the clusters and protein families. So when we look at a random collection of vectors and compare those to protein families, you get around 0.75-ish normalized mutual information. And when you pre-train a neural network, that jumps significantly up to 0.8, which means that just a pre-trained neural network, as you saw in the principal component analysis earlier, already contains a lot of information about protein families. And at this point, the neural network has not seen any biologically relevant information yet. And when you fine-tune the network on protein family prediction, it obviously, or as expected, the information contained about protein families jump up again, which is what you would expect, right? Because you're training the network specifically to work on protein families, so it learns more about protein families. But what was surprising was when we trained the network on protein-protein interactions, it ended up knowing less about protein families. And our hypothesis about that is by pre-training a neural network, the model is forced to learn general but shallow amounts of information about several different aspects of proteins. And by fine-tuning the network, you're pushing the information space into a specific direction, in this case, protein families or protein-protein interactions, but this is at the cost of generalizability, right? So if you fine-tune a network on protein-protein interactions, it learns more about protein-protein interactions, but in doing that, it forgets a little bit of its information, a little bit of the information that it learned about protein families. Yeah. And finally, we also looked at how robust Proberta is to different amounts of data. So most of the tests that we did we ran at about 20% of the data that we had on protein-protein interactions or protein families. And we did this because a lot of the other methods couldn't scale up to all the data that we had. But when we tried running Proberta on more of the data that we had, we saw a significant increase in accuracies, which was a really great sign. Yeah, but really quickly, one issue that we have is training transformers is expensive. A paper by another group that followed ours ended up spending millions of dollars training a transformer network. But our goal was to train a transformer neural network at an affordable cost, mainly because we didn't have a ton of funding when we first started working on this. So the way we did this was a two-pronged approach. One, we made architectural modifications to transformers, and the second is we use GCP for this. So by architectural modifications, I mean we use biparent coding, like I talked about earlier. Some other groups instead decided to treat every individual amino acid as a word on its own, instead of doing these groups of amino acids as a word. And that usually means that your model is a lot bigger. We decrease the number of encoder layers, and the result is our model uses 4 NVIDIA GPUs via 100 GPUs for 18 hours to train a model, whereas more complex models use 128 NVIDIA V100 GPUs for 4 days per model. And in the course of training a model, you end up training multiple models to figure out which one is the best and so on. So this is just for one model. You end up actually running multiples of this to figure out what the right hyperparameters are and stuff. Yeah, so on the other hand, when we were using GCP compute engine, we mostly use preemptible instances because that was a really good way to save money. So as a comparison here, we have on this side, the cost for a standard instance or a regular instance with 4 NVIDIA V100 GPUs for 1 hour, I believe. Yes. Yeah. So for 1 hour, it costs about $12 US. On the other hand, if you use a preemptible instance, it costs you less than a third of that cost. So it's $3.33 instead of $11.52, which builds up because you're training a model for several hours and you're training multiple different models to find the best model. So yeah, using preemptible instances on GCP is a really great way to save on compute cost, but it comes at the downside of having to make sure that you're saving checkpoints, because preemptible instances mean that your instance isn't the top priority on GCP, and it could be canceled at any point if some higher priority instance needs to be run. So you need to save checkpoints so that if your instance is shut down, you can reload from that checkpoint. Yeah, so I would like to end this by thanking my co-authors on the paper, Maeve, Simon, Sergey, Mark, and Anna. Also, Desiree, Mark, and Norman, with whom I had a lot of useful discussions about. Also, this project was partially funded by Google Cloud. It was also funded by the NSF and the National Center for Supercomputing Applications. And yeah, that is all I have.
All right. Thanks, Anandan, for sharing this. We do have one question.
So Proberta took, let me double check real quick. Yeah, so Proberta took about a day to train one model, and we ended up training multiple models with different hyperparameters, just so that we could pick the best one. But each model took about a day to train, with 4 V100 GPUs.
All right. Okay. Um, yeah, so these are, I think yeah, that's about it. So that's the question we got from our participants. Thanks a lot once again for joining us today. And I hope that our participants have gotten their answer. All right. So
Yeah.
before we end the session, do you have anything to share, like best practices or something with the participants who are interested in diving into NLP or generally machine learning?
I would say because of how fast the field is moving, the best way to learn about what is going on right now is to read current papers, especially machine learning textbooks. Aren't textbooks get you to a certain point, but beyond that, once you have the basic understanding of how neural networks work, and how backpropagation work and stuff like that, it's probably best to switch from books to reading literature that is being published. So like journal articles or conference papers. That's the best way to keep up to date with what's going on and to learn what is actually relevant at the moment, because textbooks can um, lose relevancy really fast.
All right. Thanks. And then thanks again for joining us. And I guess that's about it for this session. So yeah, we hope to see you in our future events as well. So
Thank you.
let's, okay. So yeah, we're reaching our break time right now. So it's already 1:03. I understand that yeah, we've had a very productive morning today. And once again, I'd like to thank Gwenny and Anandan for joining us today and for sharing these two, you know, interesting topics that would benefit not just students but people from various backgrounds as well. So yeah, before we go to for our break, I'd just like to share with you all about the um, swags that we have to share with you guys. Z, would you mind moving to the next slide? Okay. Yeah, so for those of you who are with us right now, we have this DevFest photo booth. It's a virtual photo booth for all of you to, access, and you can take pictures. So yeah, feel free to just scan over here that we've shared the QR code over there. So on our screen, you can just scan that, and yeah, do feel free to take a picture and share it in your social media. Don't forget to make sure that this is something that you can share with us, as we will be providing swags to some of our lucky participants who are joining us today. So yeah, while you're at while you're going for your break, feel free to just take these pictures and make a post on social media. Let us know that you're with us today. You can either post it on Facebook, LinkedIn, Twitter, Instagram, anywhere you want. Yeah, so just share with us a picture of you, or even a picture of the screen that you're watching, if you're not comfortable posting a picture of yourself. So just share it with us. Do use our hashtags GDG Cloud KL and also hashtag DevFest. We will be sharing with you guys a form once you get back from the break. So our top 30 participants who respond to this form will be receiving swags. It would be delivered to your house. So just a disclaimer, the swags are only available for participants who live in Malaysia. So just keep that in mind. Yeah, for those of you who are joining us from different parts of the globe, we truly appreciate joining us here, and we want to give you the best by providing the right content and stuff, but we're sorry we won't be able to deliver it across your country. So yeah, just keep in mind that you'll have to be in Malaysia to receive the specs. So yeah, we will be sharing the form where you get selected to be one of those lucky participants who'd be receiving our swags, and we will be having other giveaways as well later on during our event. So yeah, have your break, and yeah, let's meet up again at 1:30 p.m. So that would be in another 24 minutes. So yeah, that's about it for now. I hope you guys have a good break, and let's meet up soon.
We've already started to see the difference we can make by working together as a community.
Audio is a really powerful medium because it's so personal and engaged to who you are.
It is the most intimate and the most connecting medium. And what we're seeing today is that there's this new technological revolution taking place, and that opens up a whole new interest and explosion of audio.
Spotify is definitely more than just a music company these days. Recently, we expanded very substantially into podcasts.
I'm Alex Bloomberg, and this is Without Fail.
Our mission at Spotify is to connect 1 million creators with 1 billion fans. So that's very exciting. It's also a huge challenge.
The problem is bigger than just the number of fans that we have. It's also the amount of content that we have.
We have a huge catalog, 130 million audio files.
The scale is growing so fast. At peak, we're seeing 8 million events per second, 500 billion events per day.
Data is basically the core of running our business. And if we're not able to get the latest insights about our users, we're not able to see the key statistics about our business, that's a problem.
We were reaching the sort of tipping point where the current system wouldn't scale anymore.
And that's where Google Cloud comes in. Google Cloud takes care of a lot of the complexity of our business.
We don't need to worry about the infrastructure. We don't need to worry about all the details that aren't core to our product. It's intuitive and it makes scaling effortless.
And that frees us up to do Spotify-specific things. Being creative, being innovative, experiment faster, and get results way faster.
Google understands engineering culture, and they've really brought that to the cloud platform.
It's been a massive improvement in our ability to make our employees at Spotify more productive.
In addition, I think one of the most powerful parts of our partnership has been our engineers and Google engineers sitting together in the same room to solve some of our most difficult problems.
Because they're able to access petabytes worth of data at their fingertips very simply.
Moving to Google Cloud and their platform really freed us up to accelerate our development, and we kind of skyrocketed.
It basically unlocked infinite capacity.
Building the audio network of the future, it takes that intimate connection really to the next level, and that we believe will help us lock additional innovation in the audio space.
We have a very strong belief that we can, together with Google, build the best cloud for us.
Hi, everyone. Welcome back. I hope that you guys had a good break. And yeah, before we get started with our next segment of today's DevFest celebration, so for those of you who are with us, I hope you guys have already posted your picture on social media. We'll be sharing with you now how you can be one of those lucky winners who would be receiving swags delivered right to your doorstep. So yeah, if you're back, feel free to let us know. Just start, you can put it in the chat. Let us know that you're back, and we'll be happy to share with you guys how you can um, win those swags that you're looking forward to. So yeah, let's give it a moment for everyone to come back. And if you're back, yeah, do let us know. Okay. Um, yeah, let's get started. So, for those of you who are already here, um, we'll be sharing now how you can win some swags. So, let me just share my screen. Okay, so I hope you can all see my screen right now. If you can, yeah, okay. So, yeah, for our first 30 respondents, you guys would be receiving some swags delivered to your doorstep. So just want to share with you how you could be one of those lucky winners. So first of all, you would have to share your post on social media. It can be either Facebook, LinkedIn, Twitter, Instagram, anywhere. Just make sure that we'd be able to have a look at it as well. And yeah, it can be any photo. You can just take a picture of your screen, or you could um, take a selfie at the photo booth, the link that we shared earlier, where you can take a picture and post that showing that you're with us celebrating our DevFest today. And make sure that you put the hashtags GDG Cloud KL and also DevFest. Remember to add these two hashtags. And yeah, just a friendly reminder. Only the first 30 respondents would be receiving these swags, and only participants who live in Malaysia would be able to receive these swags because we're only able to deliver it within the country. So yeah, it's pretty easy. We'll be sharing this form in a bit. So all you have to do is fill in your email address, your name. Make sure you put in your shipping address. Try not to make any mistake with that because we'll be sending it out to the vendors. And yeah, please do fill in the postcode, city, your contact number. Make sure it's valid. the link to your social media post, make sure that it would be visible for us to look at it as well. We'd love to see your picture. And yeah, you can choose your t-shirt size and just click on submit. And yeah, the first 30 people to respond would be receiving these swags. So yeah, um, okay, I see a few questions. Just a moment. Okay, so yeah, Ali's asking for the link to sign up to the form. So yeah, we're just waiting for people to join us now, and yeah, I'll be sharing it right now. So let's start filling it up. Yeah, so you can check out your in the chat, the live chat that you're accessing. So we have posted the link right now, so it would be getting to you in a bit. Let us know if you can't access it. So just put in the chat if you still don't see the link. Yeah, it should be out by now. Also, try not to share this with others because we want to prioritize those who have actually participated. So yeah. We have a question asking if the swags are only available for participants in Malaysia. Yes, we would only be able to deliver swags to participants in Malaysia. Unfortunately, we don't have the capacity to send it out to other countries. So yeah, sorry about that. But yeah, I hope the ones in Malaysia um, would be able to access it. Yeah, we would love to give out more swags in future as well. So yeah. Okay, so I'll let you guys do that, and meanwhile, let's get started with our next event, next segment in our event. Z, we could move on to the next slide. Okay, so yeah, right now we have our next session that's about to get started. And yeah, so as you can see on the screen, we would be having a talk on machine learning in production. Okay, and yeah, before we get started, let me just briefly introduce our speaker. So today we have Shweta. Shweta works as an applied scientist at Jupiter, an Indian neobanking app built to help customers build healthy financial habits. She's also an ML GDE and has over 4 years of experience building AI first products such as conversational assistants, semantic search engines, information extraction, and recommendation systems. She has worked in fintech, e commerce, biomedical, and social media domains. She's passionate about AI and sharing her knowledge with the community. She also loves traveling, playing board games, and jamming to some cool tunes. So, without further ado, let's bring in Shweta to join us. Hi, Shweta.
Hey, hi, I'm Rita, and thank you for the kind introduction. I'm really sort of excited to be here and talk to our, viewers. I wish this was in person so I could have made the whole, session more interactive. I really love interactive sessions and interacting with the audience, but I promise I try to still make it fun for you guys. So yeah, shall we get started?
Yeah, sure. So thanks again for joining us, and yeah, we would very much love to have you here as well. Hopefully, we can do that in the near future.
Yep.
Yeah, before we get started, could you just like briefly explain to our participants what exactly is our talk going to be about today? And
Yeah,
you could
yeah.
probably share your screen as well, and we can bring it up.
Sure. Let me try to share my screen first.
Okay, sure. Yeah, while waiting for that, I guess I can just read out Haikal's comment. So thanks, Haikal, for joining us from Indonesia. We're super excited to know that you're joining us. And yeah, I hope that in the near future we could provide some swags to you guys as well in Indonesia. So let's just hope we get to, expand more and reach out to more of you as well. So thanks again for joining us. I hope that you're enjoying our session right now. Okay. All right. Shweta, you're on mute right now.
So sorry, happens all the time. Yeah. Is my screen visible?
Yep, it is. Yeah, it'd be great if you
Awesome.
could share with us a little about
Yeah.
the topic itself. Yeah.
Yeah. So you've already sort of provided my introduction, so I can skip over this slide. And folks who would want to connect with me on Twitter, I'm a little passive. I'm not that active, but I do sort of respond actively. I can promise that. So because you had asked me about like what is this talk about, I have a slide for that. Um, I'm pretty sure like a lot of ML practitioners would have been sort of acquainted with this meme, right? So I kind of relate to it in a way that I started my journey in the ML industry like about 4 years ago, and since then it's not just that the technology has been evolving, it's my role at like different companies that has also been evolving. So the kind of things that I do, it has changed over time, and my understanding of that has also changed over time. So through this talk I would just like to sort of share these nuances with the audience, and this is directed towards people who are probably maybe practicing ML in the academia or in research, or maybe people who want to start out with an ML job in the industry. I just want to sort of maybe bring in a point of view from like a real life ML project. I'm just sort of trying to bring in that perspective in this talk, because this also sort of came to me via a lot of experience, and this was not something that I was aware of early on when I started, like as a fresh graduate, right off out after my master's. So I did my master's from artificial intelligence from King's College London, and back then I was like this excited kid, and I had a different view of what an ML job. And that's why I'm not saying whether it's a scientist or whether it's an ML engineer, whether it's a research engineer. Just like my point of view, what an ML job would entail was different from now that I have over like 3-4 years of experience, how that perspective has changed. So I would like to sort of kind of narrate those practical nuances that are involved in, apart from like what is already there on the internet when it comes to like building models and training models and Kaggle projects, etc.
All right. Yeah, this sounds pretty interesting. So I'll let you get started, and I'll probably just
Sure.
drop off right now.
Sure. Thank you so much. So let me go back to my deck. Okay. So I was talking about like how I felt like back in 2017. I had just finished my master's, and I was about to like start an internship, an ML internship. And this is my view of what an ML workflow, or maybe if I just sort of land up into an ML job, this is what my work might look like. And most of it actually sort of revolved around mainly around data pre-processing and wrangling, feature engineering and extraction, scaling, selection. So everything to do prior training your model, then your modeling, etc., which is like what algorithm to choose, what considerations should you have when you're choosing your algorithm. And then after that, once you've trained like a bunch of ML algorithms, how do you select the best algorithm? How do you continuously evaluate and tune your hyperparameters, and then sort of deploy the machine learning model? So I was focused here, and if there are people in the audience who are sort of new to this field, I will take a step back and also sort of maybe give you an understanding that machine learning, building an ML model, or I would say any ML based product, involves data as well as algorithms. So that's code plus data. And both these pieces are subject to change. Like both of these, pieces in the whole projects would be changing over time. So it's quite different from, say, a software development life cycle. And it's also that's the reason why it's iterative in nature. And even to just build that software, there's a whole lot of steps that you have to go through. So this itself for me was quite overwhelming. Also, to give you a background, I was a software engineer before. So, I mean, prior to my master's. So when I kind of, when I was switching my fields, or rather when I was sort of doing like a full-fledged course in AI and learning how machine learning models or projects are built, this itself was quite overwhelming for me, because I felt like, oh, there are too many points of failure. It's not just about unit testing. There's a lot of thing going on. And I felt like, wow, I've cracked this finally, right? But this might work well for Kaggle, and this is probably the reality. I'm not sort of undermining any Kaggle competitions or Kaggle projects here. In fact, like I feel like they're a great way for you to hone your maybe modeling skills, feature engineering skills, right? Tackling, like I would say, state of the art problems. Um, but if your aspiration is to sort of work in a job in the industry, in an ML job in the industry, the story might be slightly different to what probably this sort of workflow shows you. So this sort of my myths were debunked like as soon as I joined my first job in the industry, and in my second job, which is currently Jupiter, where I'm working, right? I think I've seen a lot more than I would have sort of maybe anticipated, and that is exactly what I want to share with you guys today. So yeah, as I said, the previous workflow, or rather that I had in mind, that might work well for, say, Kaggle, but Kaggle isn't real world machine learning. Unfortunately, we don't have clean data sets. We don't have defined problems. Like when you enter into a Kaggle competition, you already know whether you have to build a classification model or whether you have to build like a regression model, right? And what is the exact problem that you're solving? The data set is already provided to you. You might have to clean it to an extent, but it is a labeled data set. So a bunch of the things are already sort of solved for you. And it's mainly the modeling and the feature engineering part is where you have to put all your emphasis into, right? And so this is what I mean, for me, this is like somewhat a representation of a real ML development life cycle, what it would look like. And so the blue portion is what I had been, in fact, when I just finished my grad school, this is what I thought I would be doing. But instead, I was doing a lot more. I was doing this orange part. I also have to sort of contribute and sort of focus towards this green part. And this was something I was not prepared for. So, I mean, it took a lot of learning, and it took a lot of, I would say, back and forth and understanding, a lot of, I mean, just generally learning from experience. I feel like the best way to learn, or rather, hone your ML skills is by working on projects. And that's exactly like, I understood that these are also the pieces that I have to sort of learn in order to build any successful ML project that is out there in the hands of the customers, say on an app, deployed on an app. So the first part itself, like, the business and the data understanding. So I'm not going to be in this talk. I would not purposely, I'm not going to be talking more about the model development part. I would be talking more about the business and the data understanding and the model operations part, because this is something I feel like this is, I mean, these days, this is kind really hot in the ML world out there, but there are lesser resources on these topics rather than, I feel like the resources and sessions on the blue part is kind of a bit saturated now. So we were talking about like business and data understanding, right? And why is that important? Why would, I mean, maybe as an engineer or maybe as a scientist, I might be just, I might find that the most fanciest part of my job is when I'm training models and I'm running these experiments, and I actually feel like a scientist. But maybe in practicality, that's not. So John Tukey, he's a famous American mathematician, and he said that it's better to solve the right problem approximately than to solve the wrong problem exactly, right? What it means is that if at the stage when you have to define the ML problem that you have to solve, when you have to take a decision whether this problem should be solved using a classification algorithm or whether we should use an unsupervised method, maybe like a clustering method or some other kind of method to solve this problem. If you haven't taken the right decision there, uh, pretty sure that you'll have to do a lot of rework and a lot of your work might go waste there. So what I'm trying to say through this is that you should take a lot of caution and sort of give a lot of time to this stage, like take out time to brainstorm with your peers or with your supervisors. Try to understand the problem as much as you can before jumping into the solution. And that is what, like, one of the I would say one of the guidelines that I have and I kind of use is always separate problem identification from solution. Because ML solutions are kind of complicated in nature. It takes a lot of effort to maybe develop, say, a named entity recognition model or a clustering algorithm and like a entire pipeline itself. And once you've built that, you might have the itch to sort of just use that solution repeatedly in a lot of different problems. But the problem is that you might not know that whether you're doing the right thing or wrong. So instead of, you should just separate this portion out. Do not think about the solution. First, just try and understand all the whys, hows, and all the nuances of the problem that you have. Try to get the entire scape, I would say, the landscape of the problem first before you jump into the solutioning bit. Translating the business objectives into ML objectives. This might sound like, again, quite clickbaity and something which has always been said so many times. But in the real world, I can say that, this, an example is like, maybe if, say, the business comes and tells us that, I want to reduce my cost on customer service and I want to improve the experience. And this is the business objective, right? This is not, nobody's telling you that you have to go build this model. But how do you translate into ML objectives is that if the solution sort of demands, and if you have the resources, and if after you do the user research, if you have some data, and if you validate all of those assumptions, you can figure out that you might have to build like a chatbot. That would be the ML objective here. And within that ML objective, because a chatbot entails a lot of things, that can include a bunch of ML models, a flurry of algorithms, also a lot of engineerings, right? So this is one way of, if you have the right understanding of the business problem, translating that to the right ML problem is also a very important skill. The other things are like, assessing feasibility and ethical concerns. Feasibility from the point of view of like, do you have enough data? Do you have enough resources? What are the timelines? Do you think you would be able to manage like an ambitious project within like a constrained timeline? Or should you first start with, say, maybe a heuristic-based solution and then slowly and steadily evolve it into a more ML, based solution? The other thing is the ethical concerns. Is your data sort of, do you have any privacy concerns? Can you access that data? Are there any regulations? If not, how are you going to collect that data? Are the resources, ethical or not, right? The other thing is, once you sort of have this understanding that I know what the problem is, I have done this feasibility analysis and everything, you need to lay down certain specifications. So you need to sort of define how would you measure the success of this project, like this ML project, right? So you have to define what ML metrics are you going to use to measure the success of this project. what business metrics and software metrics are also going to be there. ML metrics could be something like accuracy, precision, recall, right? Say maybe for a classification algorithm. And business metrics are something like maybe how much cost are you reducing? Software metrics, on the other hand, could be what should be the latency of your model, or like how quickly can it serve the user, how much compute are you going to use for this, right? Then the resources and the timeline itself, you have to budget for that right in the beginning of the project. And again, I would say, like, to sum this up, there's also benchmarking required for any ML project that you're sort of attempting in production or in the industry. If there are any prior benchmarks, say anybody else has built the same project, you need to benchmark from the timeline perspective, the metrics perspective, the resources perspective. If it is not there, say you are building out, because a lot of ML projects are actually maybe the first projects that maybe you're building in a new domain or a new company, and there's like a totally new problem. In that case, maybe building out a POC, which is it makes much more sense than directly jumping over to the solutioning bit, right? Moving over to the data part. So there was business understanding and data understanding. This has been there. This sentiment has sort of evolved through a lot of experience that when you find out that machine learning really means endless data cleaning. There are a lot of new, I would say, talks about this recently. Andrew Ng also had a talk about this, like data-centric methods of machine learning. And this is not really talked about a lot, but if you are an ML practitioner in the industry, I think you might be aware of this, that a lot of machine learning actually involves preparing good quality data sets, preparing representative data sets, even, and that is the reason why understanding and collecting the right data is crucial from the beginning of the project itself. So whenever you're starting with a project, say in the industry, you always have to think about how you're going to collect that data. Are the resources available to you? Do you have big versus small data problems? Like sometimes people might have huge amounts of data, say millions of data points, and then the struggle becomes how to sort of reduce that into the most representative data set such that your model is accurate as well as generalizable. And that's a complex problem in itself. The other problem is small data problem, that maybe you're working in a cold start scenario. There is the data set is really small, and it's not enough for you to build an accurate or a performant machine learning model. Then what do you do? What kind of techniques, data augmentation techniques, do you resort to? Annotation is important because most of the ML models in industry, at least this is what I think, and it might be the general consensus also. These models are actually supervised learning models. That means that they need annotated data sets, they need labeled data sets. So as I said, when you are practicing ML maybe on Kaggle, you already have labeled data sets. But when you're doing that in the industry, you have to take care of how these data sets have to be labeled, what those labels are going to be, and how would you define the definitions of labeling, say, for each class, or maybe labeling for, say, if you have a NER model, like a named entity recognition model, how do you define an entity and each classes, right? And then you also have to make sure that this labeling has been done to the best of quality. That means maybe multiple people are labeling the same data, and then you are trying to rule out any contradictions by a voting method, or you have somebody who can review that, or maybe you yourself have to review, say, a sample of annotations and give feedback to your annotation team. A lot of times, maybe when you're working in really small companies, people might not even have the bandwidth or the cost to sort of afford any data annotators. In that case, a lot of times scientists or ML engineers themselves have to label, say, representative data, and then think about how to augment this data by building some prototypes. So that's again, like, this part is never sort of considered, but this is kind of the grunt work that is essential for you to make sure that the ML solution that you're building actually sees the light of the day. Again, data provenance just means that where your data has been acquired for. So you have to be aware of these things, because otherwise they can lead to any kind of regulatory issues. Lineage just means that, building data pipelines. So sequence of steps that you have done to maybe acquire and then clean and then prepare that data. These pipelines need to be automated for you to make your life easier. Hand in class imbalance, I think, like, most of the people who are sort of practicing ML might be aware of that. But the truth is, the real world data is skewed. There are no perfect distributions, uniform distributions when it comes to looking at real world data. And that is why this part also is crucial. And a lot of times this is sort of overlooked, and that leads to a lot of failures in production. Yeah, something as simple as this. Cleaning and normalization and data augmentation, I already talked about. It's just about how well you prepare your data such that it's representative, and it's also normalized in a way that there's no skewness, or the features are not just out of bounds. These things you take care of when you're doing your data pre-processing and wrangling steps. Another very important thing to sort of take into consideration is the data versioning. Because you'd be having different versions of the same data set. Say I'm working on some kind of a movie data set, maybe my first data set and my second pre-processed data set, and then again, maybe I've normalized the data set. I would have like 2-3 versions of the same data. And then that version will also change. Say my model is deployed. I already built like a movie classification model, and that is deployed in production. But then there is new data coming, and I will ingest that to my existing data set. So in order to make sure that my model still works on the new data, and that is how my model and my data, that both their versions will change over time. So this is something that you have to sort of imbibe in your system, that both data and your code will keep on changing. So as I said, that in this talk, I'm not going to focus on, the ML modeling part too much. So I'm already assuming that, say, if you have understood the business understandings and the problems, basically, if you've understood the problem and you've defined the problem well, and also you've understood your data definitions, like what is your input variable, what is your output variable, what are your constraints, and whether you have enough data or not, and all of this is already done and your data is prepared. I'm assuming that these days, anyway, you have a lot of pre-trained models for a bunch of things, especially like with respect to deep learning and transfer learning. But even if you're, maybe practicing traditional machine learning, the modeling bit, because of these frameworks like scikit-learn, TensorFlow, PyTorch, right? These, I feel like writing code is no more that much of a hassle. But what comes after that is like the real big hassle, in my opinion. So I'm assuming that you already have a trained ML model. What you do after that? Yeah, here comes the technical debt. So say I train this nice, generalizable, accurate model, and I have like all these best metrics. Like I have 98% of precision and F1 score. Say it's a classification model. Maybe 98% is too much. I'll maybe lower it down to 95%. And I'm very happy that now my model is going to production, and say this will be deployed on an app, and now real users are going to use this. But the story doesn't end there, because there's a lot of technical debt which is associated with any ML product or any ML solution or feature. And let's have a look at all of that. So this diagram might be familiar to a lot of you folks. I think this paper was authored by a bunch of people at Google and also a lot of other organizations. What it is trying to highlight here is that the entire ML code, as I was saying, right, writing ML code, or just the modeling bit, maybe not be as complicated nowadays, or like a tedious task, but The other bits like collecting data, verifying that the data is clean and correct and representative, managing your resources, the analysis tool. This will happen once your model is in production, right? You would need to do a lot of analysis of your inference data, which is like your production predictions, basically, whether they're correct or not. If they're not correct, how do you improve your model? Because there might be rollbacks. Then monitoring again is a part of that. Config, yes, config is again something that keeps on changing. Maybe you have, say, a TensorFlow model and with a certain config right now. 2 months later, you want to replace it with, say, a PyTorch model, and there's another config itself. So the ML code also has a very, I would say, it has an unpredicted shelf life rather than a very small shelf life. It just depends on how well did you choose the architecture when you just started with the first version of the model itself. And the serving infrastructure as well. So you see that there's when and this is something, this is kind of an epiphany for me, and this is what I discovered, that what I had in my head was maybe a very an important bit. I'm not going to trivialize that. Training an accurate or a performant ML model, something which is stable enough to go to production, that itself is a big achievement. But if you want to continue that, I mean, if you have the desire that your ML solutions are not probably maybe there for a while and then they get replaced by something else, rather you want the same ML solution to just evolve over time and build such systems that can scale as well, there's a whole lot of other things that you need to also sort of learn. So this, again, as I said, it was quite overwhelming. Okay, how do I even start with managing these projects such that I'm not so overwhelmed and I can maybe take certain precautions and take certain best practices right when I start the project? One thing is your project structure. Again, through experience, and I went through this, and this is why I feel like this is extremely important. Not that this is not from my own notebook, I copied it from the internet. But yeah, this may happen that you want to run like a quick model training pipeline, and then you want to try something else, maybe a different architecture, and you're not really maintaining good project structures. That can lead to a lot of clutter. This also goes for your data. This also goes for the other artifacts that you produce with each model. A lot of models also might be tied with some certain kind of embeddings or maybe pickle files, right? So you need to have like a proper project structure right at the beginning of your project. And this is extremely important. I kind of recommend this link. So you can, I'll share my deck with the organizers and you can check out this link. This is basically cookie cutter data science GitHub project structure that I would sort of recommend. And I have personally used that. And I feel like it just organizes a lot of these artifacts and a lot of these resources that are a part of any ML project and ensure that the clutter and the disorganization is minimized. And I feel like if that happens, so would your thoughts as well. The another problem that maybe, even if you've deployed a model next time and you have trained a model on a small data set, but next time, now that the predictions are there, your data set has become large. And now that you're training the model, it's taking just endless amount of time. So how do you tackle this problem that sometimes when you have less data, you can frequently train your models quickly, but as in when your data grows, or maybe you're choosing like a complex architecture, you're choosing like maybe heavyweight embeddings in your model, this would happen pretty soon. And this can be frustrating because if you don't have anything in between, if you have to constantly go and check, like, when your model has trained, it's taking like 1 hour, it's probably not, you're not going to be as productive. So how do you speed up training? One thing is, as soon as you figure out that maybe this is the model that I want to train and deploy in production, and you've narrowed down to say one architecture, even before that also you can automate your training pipelines. So it's a good practice to, so you can do it in notebooks. I think there are tools nowadays that provide this capability whether it's your notebook code versus whether you want to convert it into Python scripts that can be run over, say, cloud or some other machine, instance, such that you don't have to run it in your laptops all the time, and that too manually. So building automated training pipelines is a must. Maybe training it on a cloud machine, which has better compute. If your own personal local machine doesn't have, would be a great idea. Reducing your data size is also something important. Maybe a lot of times what we think is that now that we have these deep learning tools available, we can just dump all the data and it's okay, right? Your model would be trained. But through practice, what I have figured out is that more than a lot of data, better quality of data is the most important thing at times when it comes to the high performance of your model, and making sure that your model doesn't overfit and fail in production because of data drift, or maybe say concept drift, right? So I wouldn't say it's a wise thing that if you have a lot of data, just use all of that for training your model. And that might also solve the problem of speeding up training. The other thing is, just try to get more compute. If you don't want to spend too much, maybe try with the free GCP credits. I'm pretty sure like a lot of other cloud providers also provide certain free credits for you to get started with. And if you are, say, a small company, if you're working in a small company, you can maybe try to apply for the Google for Startup Accelerator program. They would help you with free GCP credits for your company up to a certain amount, say 1,000 or 2,000, and that would sort of give you extra credits to experiment with and use. And eventually, if you feel like this is the cloud provider that you need for training your ML models and maybe deploying them and serving them, then you can go ahead with more full-fledged plans with them. I'm not really selling GCP over here, but this is inevitable that once you start, you cannot always train your model in your local machine, and that's a fact. So the sooner you switch to a cloud instance, whether it's a free one or a paid one, the easier your life would be. Distributed training, again, like you can also make sure that you use of this multi-node training architecture, so that your training is distributed across multiple pods and not just on one instance, to speed up your training as well. Okay, another classic problem that people face is, and this has happened to me as well, is there's a defect in production, but it works on my machine. What could be the possible cause of this would be that maybe your production environment and your local environment is not the same. This could be one of the causes. I'm not saying that this is the only cause. There could be other causes as well. Maybe there's a slight difference of the config that you shared, or that has been sort of used to serve this model. But a classic, I would say, reason is that your local environment is different from the production environment. So just to avoid that, we should make sure that you use containers like Docker, so that you package all of your environment and dependencies, and make sure that the same environment, your prod environment and your local environment is exactly the same, so that you can replicate any of the errors, or just general reproducibility sort of will get, I would say, enhanced. And if you use Docker containers or any other containers for that matter, make sure you have a virtual environment set up. Try not to run everything on your base environment in your machine when you start with the project. So this is just my practice, that I create a virtual environment for every project that I sort of start with. Unit testing, even though it's an ML code, unit testing is absolutely important. A lot of times, because we're working with data, we never sort of maybe take care of things like, what if the input was null? What if the input, say, if you are handling text data in a certain language, what if the input is in some other language? Like, for example, in India, there are too many languages that users use, right? So I might have built a chatbot that speaks in English, but then people started typing in Hindi, and they can always do that from their keyboards, right? So have I handled for these scenarios? And if you do the unit testing well, if you build for such test cases, you can avoid such failures that can kind of amplify in production. Again, I would sort of suggest on not reinventing the wheel. A lot of companies, a lot of people try to build their own ML platforms, but I feel like there are already a lot of open source solutions and tools out there like Polyexon, MLflow, Qflow. They're just a few. This is no recommendation as such, but some of the tools that I'm aware of, there are other tools as well, which you are free to use. So, and I'm pretty sure there are a lot of articles on deciding which tool is more suitable for your requirement. So go through them and maybe you can pick up one tool, and whatever requirement is not suffice through that, maybe that is the bit that you can create by yourself, that particular functionality. But the rest of it, I would say, do not reinvent the wheel. Okay, so as I've been talking about, like, the modeling part, we didn't even talk a little bit, but this is just the infrastructure part. So you have the model is already done there and you're not even touching that. It's just after that and prior to that, the entire infrastructure that you have to build, it really feels like a huge amount of work. And to give you a taste of that, so once the model is built and everything is done, this is what an ML sort of ops pipeline looks like. So from data analysis to like DS experiments, this is where your model was sort of built and decided this is the model that should go. Analysis has already happened. Then you push your model to a source repository. You have to introduce CI/CD pipelines here for building and testing and deploying. Once that is done, there's again a whole lot of data engineering and ML model engineering involved for serving your model and for for collecting your predictions, and then for the performance monitoring bit. And this would lead to the triggers. So through performance monitoring and logging, you can understand if and when, like, do you need to retrain your model, or the existing model is good to go. And this would again lead to data engineering. So again, this iteration kind of will continue. Sorry, endlessly. So as I said, this from the first slide, when I was thinking from 0 to 1, I would say when you start building the first iteration of a model, there's a whole lot of work that goes there. But after that itself, just to maintain that model such that it doesn't go stale, it is we don't have to roll it back and say if your application is consumer facing and your product feature is totally dependent on that, that would be a really bad experience. So just to avoid and maintain that model such that it just stays at it as it is, this is a whole lot of things that are supposed to be done. So one thing is model inference on edge devices, and this also sort of I learned with experience that when we are building these models as say research projects and all, when you have to load the model, you try to create this load function and you load the model there. But just think about it. When you have to have these inference, say for a streaming data or say for a batch of data, you cannot be loading your model again and again because that would be a costly operation. Some of the deep learning models take a lot of time to load, right? So what's important is for you to host your loaded model as a service. And this is what model serving is all about. So your model is trained and then your model object is loaded and it's exposed as a service. And that service is then generally called by different applications. It could be a smartphone device, or it could be through some API and your client can access that. This is again really important. And there are too many tools, I would say, that already provide this capability. TensorFlow serving is one. There's Bento-ML. There's Onyx also as well, and there are a couple more. I'm not recalling all of them, at this moment, but definitely there are way more, and you should definitely explore using them for serving your models if you're deploying your model to, say, an edge device. Yeah. So even after all of this, even after choosing the right sorry, model serving tool, you cannot just simply put your models in productions. There's still a bunch of things that you need to take care of. One thing is the system monitoring and logging bit. As I said, when the new data is ingested, say your model is exposing, again, like say it's a movie categorization app that you have, and users are maybe entering movie names and they want to know what is the category of this, whether it's a romantic movie or an action movie or a thriller horror movie. So the entire data pipeline, which is like pre-processing exactly as you did during training, is going to run here. The inference is basically making predictions on your trained model. And through that, this data augmentation bit is basically adding that data again to your training pipeline, reinforcing your model, deciding like, which data point should be added to my training data in order for me to make sure that my model is not, is still able to predict well on incoming data and its performance is not going down. That's the main objective there. And that feedback gets added, and your model will eventually be retrained and replaced. Handling the data drift. Okay, this is one extremely important part and something which requires a lot of thought, a lot of intelligence, and I would say a lot of resources as well. So this is the active learning bit. What happens is that we generally train, if it's a supervised learning model, we generally train our models on fixed data sets. So maybe you picked up, say, 10,000 or 20,000 data points and you trained a model and it's there in prediction. But when you get raw unlabeled data, when you actually make predictions on, say, a live app, that data might be in millions, right? So my model has been trained on, say, some thousands of data points, but my the raw unlabeled data on which my model is predicting is it could be infinite, but let's just assume that's in millions. I and maybe you don't have the compute to add millions of data points and train these large models. So what are you going to do? What is important here is for you to carefully select the data points that should be added to your training data in order for you to retrain your model and restore its performance. So, say for 1 million data points, there might be, say, a few thousand or even less, right? Maybe if your model is already performing really well, maybe some few hundreds of data points on which your model is performing poorly. So identifying them and then sort of augmenting that into with your training data set and retraining your model is a complex problem, because how do you sample that data? You cannot just run, I mean confidence, your model's confidence is one aspect, but there could be different other strategies, and these are active learning strategies that you can use. And the only objective that they have is sampling the right data set that needs to go for annotation, and that annotated data set has to be added back to your training data set such that your model can be revised and replaced. Performance evaluation again. So, say you found these 100 or 500 data points on which your model performed poorly. It makes sense for you to add this to your training data set such that your model learns to predict correctly on these data points. But how do you evaluate the performance as to what you're supposed to do? Whether you're just supposed to add this data point, or maybe your model architecture needs to change as well, or maybe there is some data cleaning step that was missed out and that can fix this. This can be done using some error analysis. This might seem tedious because it's manual to begin with. There are ways that you can automate parts of it, but usually maybe analyzing, say, 100 or 200 representative sample errors would already provide you a good idea into where you should put your effort. Should you change the model architecture, or should you focus on just adding these data points and making sure that your model is more representative? Or is there any other direction that you should sort of proceed towards improving the performance of your model? Okay, so I'm not sure if I went through like really fast or not, but this is almost the end of my presentation. What I wanted to sort of convey through this was that the life of an ML project in the industry versus maybe in research or in the academia, especially like on Kaggle, is quite different. And there are tons of things, there are too many things. And apart from these, I would not just say so, from what is already listed on your screen, which is the planning and the project setup, the data collection and the labeling part, the training and the debugging and the deployment and testing, and even then the monitoring and maintenance, right? We discussed all of this. But apart from that, there are a lot of other skills, such as how do you convey the results to your stakeholders? How do you ask the right questions to, say, the business folks, such that you're able to understand your problem better? And then eventually, how do you sort of make sense of your model predictions? Like, do you have an idea where your model is performing well and where it is kind of failing? That is really important for any ML practitioner to know. So these skills are also extremely important. And there are already, I mean, some of these things only come through experience, as in when you're working in an organization or you're working on such projects. But a lot of the other skills that I mentioned in this session can be built over time. There are a lot of resources out there. MLOps is like an extremely, I would say, trending topic these days, and rightly so, because the whole modeling bit is, I wouldn't say that it is already completely saturated, but at least a lot of models that can be built in production, they can be done with the infrastructure and with the tools that are already there. But the maintenance and the monitoring and just the infrastructure part is something which is still unsolved and evolving. So yeah, thank you so much. I would love to have your questions and answer them. um,
So thanks a lot, Shweta. We do have a question here.
Okay, so this question is that when the business pushes for more experiments, best practices often go out of the window. Do you have any anecdotes on how to get data scientists to follow best practices and governance policies? Okay, I kind of do understand that. So when you're saying that the business is pushing for more experiments, I feel like if I'm a data scientist, it's not just about something has been pushed down to me. And I know that a lot of companies are, these instructions are sort of top driven. So you'd get the instructions from, say, the leadership, and then you have to follow that. But as a data scientist, I should be aware that if I am conducting this experiment, is this important for me to do or not? You can do 10 experiments, but maybe just by looking at the problem, just by analyzing and understanding your data well and the business problem, if you have good understanding of that, you'd be able to eliminate that, these 5 experiments are anyway not important for me. So prioritizing and strategizing is as much a part of this as is anything else, as your technical skills. So you should know what to prioritize when. For example, if maybe I don't have a lot of data and I am asked to build like a complex deep learning model, say, and I don't have good representative data, I might not venture into that and wait for more data to get collected. Maybe go with a very lightweight traditional ML model to get started with. But that's also important to do so that you have a way for yourself to collect more data, and so that you can keep on going. So instead of and that is the reason I said that, how you communicate to your business and other stakeholders is extremely important, because you cannot throw a lot of jargons at them, but at the same time you have to make sure that you make them understand why certain decision is important versus why something is not important, and make sure that you do sort of feature, the cost associated, the time associated with an experiment. And once you've provided all of these, I would say, specifications, I think probably they would also understand better that probably it doesn't make sense at this stage to have so many experiments.
Right. Thanks for answering that, Shweta. I hope we've answered the question. We have another one. Okay, I think this is from the earlier bit of the session. So they're asking how can the skewness of data be reduced?
Sure. So skewness, it can be like there in classification or even clustering problems as well. Any kind of problems, I would say. But most of, say, the ML problems in the industry, as I said, like they're supervised, right? So I'm going to assume, say, it's classification problem. Say you have to build like a multi-class classifier and you have a skewed distribution. There are multiple ways to solve that. One would be that you try to gather more data for the minority categories. But if that's not practically possible, is it possible for you to reduce the data for major categories? If that is also not possible, there are other resampling techniques. So there is smooth sampling techniques. What it does is that it doesn't sort of reduce or overpopulate, like duplicate your data. Instead, it kind of converts your data into high dimensional features and creates replicas out of that. So it handles the skewness in your data automatically without even you having to just duplicate your data or just cut short your data if you have any data scarcity issues. So these are certain ways. Of course, there'd be like other techniques as well, but these are just a few ways to get your skewness into check.
Thanks for answering that, Shweta. Apart from that, we have some comments here saying how relatable it is. Um, yeah, I can totally agree with that. I mean, like, when you mentioned like how much of like understanding the business itself and all that, I think even when I first graduated as a student, I didn't quite think of that. I thought it was mostly going to be, as your role as a data scientist, like what you do is mainly just working on the models and stuff. And then you realize the business requirements and, even
Yeah.
cleaning up the data and all takes up most of the time. So yeah, I
Yeah.
totally agree with that. It's very relatable. Yeah, apart from that, we have another comment here. Um, yeah, we also have a question. Let me just bring that up. Okay.
Okay,
Yeah, so
so
Mengon has a question. Yeah.
hey Meng, thank you for the question. How to handle big data for model training? This again depends on whether you have compute available or not. And also, I think one of the important considerations is, does your problem require big data? For example, if you're building like a large language model, like training a large language model, I did work on a project last year, research project like that. And it made sense for us to use a huge corpus of data, and the only resort we had to sort of make use of that. For example, BERT has been trained on a huge corpus of data. And at this moment, there is no way to replace that corpus and still have a model which is as, which will give you such high performance. So in that case, the only way you have is to resort to like a higher compute, like maybe GPUs, or if you have like extremely large data, then use TPUs to train your model. But apart from that, the other way is you can, I mean, in terms of handling data, I would say you can use Spark framework for handling your data, such that you're not just running out of memory in your notebooks. The other thing is just try to reduce your data size. Try to, of course, like initially when you load your data, you will have to use some kind of a Spark kind of framework so that you're able to load everything. But your objective should be to reduce your data size and make your data more representative and remove all kinds of noise and unnecessary things in your data, because that will eventually mean that you wouldn't need a lot of compute for training your models and maintaining them as well. So it's going to be economical. But if you don't have that problem, then you can always use GPUs and TPUs for training your models.
Okay, so Mengon, I hope we've answered your question. Feel free to just reach out if you have more questions as well. We've dropped in the chat how you can reach out to Shweta in future as well. So feel free to reach out to her, via LinkedIn or Twitter. Yeah, apart from that, so thanks a lot, Shweta, for joining us today. It was truly a pleasure to have you. Yeah, before we end our session, do you have anything to share with the participants? Like, yeah, a quick note for them. Yeah.
Yeah, so it was my pleasure as well to speak here, and I would sort of love to be there in person as well. I was planning to visit Malaysia like since 2 years, but COVID happened. Another anecdote that I can share is that one of my really good friends when I was doing my masters in London was from Malaysia. So I love people from Malaysia. I think I bond with them a lot. So yeah, I'm very happy to be sort of interacting with the audience and speaking to you guys. Thank you so much.
Absolutely. We definitely enjoyed the session, and please do reach out to us if you ever happen to visit Malaysia. We'd love to have an in person session with you. So, thanks once again, and hope we can have you on our session in future as well. So, yeah, thanks, Rita.
Yeah, I would love to have that. Thank you so much,
All right.
Amrita, and thank you, everyone. Have a good day. Bye bye.
All right, everyone. Yeah, we're going towards the end of our session, our event today. Yeah, before we move on to the final talk, just a reminder for those of you who are here right now, who have joined us, who have joined DevFest, throughout the day, any time of the day, you are entitled to, win some swags if, if you're one of those lucky 30 participants. So we have put in the chat again. If any of you would like to, receive swags, feel free to just fill in this form. And yeah, just a quick reminder again. We would only be able to select participants from Malaysia. So make sure that you're in Malaysia if you're going to fill up the form, as we wouldn't be able to send it over to other countries. So yeah, I hope if anyone is interested, just feel free to fill in the form. So yeah, moving on to our final session today. I think it's a very you know interesting one, and I'd say that it's something fresh, an idea that we didn't quite expect initially. So yeah, we have um Jack joining us right now. And yeah, before we start with the session, I'd like to briefly introduce who Jack is. So Jack is a third year computer science student from University of Malaya. So he's currently interning in the MLOps team at Money Lion, and he likes planes, so hyperplanes. I'd love to know more about that. So before we we move on to the session, let's just bring in Jack and also share. Okay. Hey Jack. Okay, I think you're on mute. Yeah, you're on mute right now. Okay. All
Hello.
right. Thanks for joining us, Jack. I mean, it's
Can you hear me now?
yep, we can hear you.
I
Super
can't.
exciting
Yeah,
to know
I
more
can't get the
about your
sound to
topic.
work when I'm on the stream, yeah. So I have to listen to the stream.
Oh my. Okay.
Okay.
I guess
Yeah,
I'll
this is
try
not
to
good.
talk less then, and I'll
Yeah,
probably just
I can't
hand it over
hear
to
you.
your session then.
Sorry. Yeah, because the stream has a delay as well. So every
I
time I
see.
speak, it takes some time to get back.
Okay, so I guess I'll just hand
Sorry.
it over to you then.
Why is the sound wrong? Sound wrong. I suppose I can start. Okay. Sorry I couldn't hear you, Amrita. Okay. Anyways, oh, it's probably because of the screen. Anyways, thank you for having me. Okay. Hello, everyone. Good afternoon. So as Amrita has already introduced, I'm Jack Min. I'm a data scientist intern at Money Lion in the ML Ops team. And today I will be presenting on how not to code like a noob, write code that engineers and future you want to deploy. So, hello. Is this like them? Okay. So who is this for? Who are these noobs I'm referring to? Well, actually, you'll see in the examples, this noob I'm referring to is myself. A lot of these code examples are my own code. But I also think that this talk is very helpful for people who want to write code that is more readable and more maintainable. So this could be like job applicants. So when you apply for a job, when you write code that is just like beautifully documented and type hinted, I think that's pretty impressive. And if you're just a fresh grad or junior developer who's like starting off your development and like you're having trouble getting your code you're having trouble getting your PRs through the code review, I think like being able to write more readable code is definitely helpful in that sense. So I guess the talk is for any developer who wishes to increase the maintainability of their code. So or any developer who's experienced something like this. I think most people who've done development before have experienced this before, where on Friday evening you think that okay, I'm done for the week. I'll come back on Monday and finish it, and then you come back on Monday and you don't remember what you did. Yeah, so I guess this talk is to help with that. And so the most important thing I think I want to drive home, if there's nothing else you remember from this talk, just remember this one thing, which is that code is read more than it is written. And so as a corollary of this, you should write code in such a way that it optimizes for the people reading it rather than the people writing it. Like, yeah, it may take you like a few more minutes of time to write code that is more readable, but I think it saves you like hours or maybe even days trying to understand what you did or trying to debug some sort of semantic error that you have in your code. Yeah, so definitely I think code is read way more than it is written, and we should always be optimizing to write code in such a way that it is easy for people to read. So, okay, so what are these tips I have for writing more readable code? So I think the way that the talk will be structured is I'll sort of give small tips and yeah, because I think, yeah, you'll see. Okay, so first, starting off, names matter. Don't give your variables stupid names. Don't give them undescriptive names that like when people read it, they have no idea what you're trying to do. So common offenders, people like to name tables A, B, BB. A lot of iterators do IJK. A lot of times people use variable data. Like I think every single variable is data. So I think naming it data doesn't tell you that much. Full temp sort of things. So I have a little example here. This is a code I wrote when I was a first year. So take a glance at this code and see like, can anyone make a guess as to what I'm trying to do here? And like, I think obviously if you're trying at home, this is really hard because the variables are just like named really weirdly. You have no idea what I'm trying to do, like trying to iterate for char I in uwu. Okay, and so I've grown a bit since then. So I came back and I renamed the variables. So now take a look at this piece of code, and you'll see that even without directly reading the code, I think if you glance at it for like 5 seconds, you at least know what I'm trying to do. Because here it's obvious that I'm trying to construct a board component. As you can see, there's board here, board there. And whereas over here, it's not that obvious that I'm trying to construct a board component because I'm naming my board component out because it's the output, which again doesn't tell you that much because a lot of variables are output. And obviously, this is just sacrilegious naming. I guess I just wanted to entertain myself and name a variable uwu. And the only way that you could figure out that uwu is a board is this line where it says print board. Whereas over here, since the variable is named really well, you just know that I'm trying to interact with the board. Here you can see the iterator is named better. You know that I'm trying to iterate through the squares instead of iterating through the I, whatever that is. And yeah, overall, I think as you can see that naming your variables really makes a difference in terms of readability. And I think most people would agree that this code is much more maintainable than whatever this is. Okay, next thing about commenting etiquette, which is why is better than what? So I think this is quite common a lot of the time because when people teach programming, they usually tell the first years like, oh, you should write comments in your code to improve maintainability and like make your code easier to read. And a lot of the time, I think the default way that people comment is they will tell you what the code does. So something like this, where it's trying to make sure that the length of transactions is more than equals to 2. And they've written a comment over here, check the number of transactions must be at least 2. It's like, I know the language. I know that this is checking to make sure the transactions at least 2. But the thing I don't know is I don't know why you did it. And so I think this is a better use of comments, is that you shouldn't be telling people what your code does, because people who are reading your code know the language, right? Like you don't need to tell them how the language works, but you need to tell them why you did something specific. And so a better comment would be like a weekly income cluster must have at least 2 transactions. Because here you are telling people why you are doing it. Like, I know what you are doing. You are making sure that the transactions must be at least 2, but I don't know why. And by putting this comment here, you are telling me, okay, so I know why you've put it here. It's because of the rules around weekly income clusters. Another example over here again, you can see for those of you who are familiar with pandas, it's a 10 cluster transaction. It's being sorted by the posted date in ascending order. And the comment over here is sort transactions by posted date in ascending order. So again, it's just telling you exactly what the code is already doing. Again, not very informative. I'm not exactly sure why you've done the sorting. And so I think for these type of comments, it's best you just don't write them because they don't add anything informative. And a lot of the time, I think commenting can become quite dangerous and increase the amount of code depth you have, because on top of maintaining your code, when you write comments, you also have to maintain your comments. And sometimes what happens is that people write comments about what is happening in the code block. And then later on, like a few weeks later, once they've lost that context in their mind, they modify the code and forget to modify the comment. And now the comment becomes wrong. Like, for example, if later on, for some business reason, we want to instead sort the cluster transactions by descending order, and someone changes this and forgets to change this comment is now wrong. And so I guess that makes it even worse. So again, to take back what was said in first year, I think to every computer science student, like I guess most of the time, yes, it's better to comment than not to comment, but you should use comments sparingly, because like commenting everything is not easy to maintain. And you very much should be thinking about whenever you write comments that you're explaining why instead of what. Okay, next thing, docstring. This I think happens a lot. I mean, it's not something that I think is taught very often, but I think people who have maintained big code bases really appreciate it, which is that it's always a good idea for you to have at least some amount of docstring so that people know what your function does, right? So this person who wants to know what your function does is likely to be future you, because you're going to write a function that you use everywhere. Then 2 weeks later, you're going to forget what it does, and you're going to call the help on it. And if you don't write any docstring, you'll get something like this. And okay, I guess I can kind of guess what it's doing because the variable names aren't too bad, but I'm not sure what the types are and the return is. Okay, so it's making a safe request. Is this request function the callable of the function? Is it a string reference to a function? Is this timeout a boolean, or is it supposed to be a float or an int of like how long the timeout is, or it's just turning timeout on or off? And like, what does this request even return? Is it returning me the JSON? Is it returning me headers? Is it returning me the content? Like, I don't know. Like, obviously looking at this, you have no idea what this code, you have no idea what this function is doing. And what ends up happening is you have to go and, do your grep thing, find the function and reread what you've written, and have to go through this abomination of code. And then 3 minutes of your time is gone. You lose your train of thought and you forget what you were doing. Okay, and so I guess this happens often enough that at some point you realize that, okay, it's a good idea for me to write docstring so that whenever I call help on a function, I get more context about what this function does without having to read the logic. And so here, this is the docstring for this function. So you can see that, okay, now it's quite clear that the request function I put into the save request is a callable. I know that my service names, path, URL, all these are string. The timeout is an int. There's a default value of 10. There's a longer descriptions of these parameters. There's a short description of why this function was implemented and roughly what it does. It tells me what the return type is, that it returns the JSON response, the dictionary, and it gives me this very important piece of information, which is that the reason for having the save request in the first place is that a lot of the time when you make requests may fail, and you'd want to return an error message instead of your server just crashing or your front end just giving people blank pages. Like you want to inform the user of how to resolve the error or whether it's their fault or it's the server's fault. And so what was important here was that this function raises this circuit breaker exception. And so I think, I mean, if you read the code, you could have figured this out. But again, I think reading this, you would figure it out in 10 seconds. Reading this, it would take you like 3 minutes to figure out that what this function was trying to do. And so again, I think writing docstrings is a good idea. Again, I think on this thing of docstring, you don't need to be perfect. Like as long as it makes you read the function logic a few times less, and it puts you in lesser meetings where you have to explain your code, I think like that's all that needs to happen. Like for this save request function, I actually use this function a lot in my code for circuit breaking, because you know in microservices, having circuit breaking is very important. Yeah, and so I use this function a lot, and so it's a good idea for me to document it very thoroughly. But this function over here, I only used it once, but still, I think it was a good idea to write just a little bit of docstring so that when I hover it over it in the IDE, I immediately know what it does, and I don't need to look at what I've been trying to do over here. Again, as you can see, this docstring is not perfect. It's not explaining what is being returned and everything, but I think it helps at least a little bit in that it gives a longer description and more context of the function. Okay, next one, modularity. I think most engineers who have deployed data scientist code, this is their main complaint. Because like in preparing for this talk, I did go around my company and ask people, okay, what is the one thing that you wished all the data scientists knew how to do that would make your life easier? And like pretty much every engineer, the first answer they go for is modularity, which is the fact that I wish these data scientists didn't repeat themselves so much and didn't write giant blocks of code with one function. Okay, and again, I think most people who are in software development, you hear this a lot. So you hear the dry principle, don't repeat yourself. But a lot of the time, I think people they don't tell you why don't repeat yourself. And I think one of the main reasons not to repeat yourself is that when you repeat yourself, your code becomes quite hard to maintain because it's very hard to unit test. Yeah. So you can imagine if you have like a giant block of code when you're writing your unit test, like it just becomes like the amount of combinations that can go through your giant block is just endless. Whereas if you had isolated individual components, testing the individual components is much simpler, and you end up with more maintainable tests than when you're trying to like unit test the entire monolith. So just having giant blocks of code is just the bad idea. So again, but like going for this modularity, right? I think a lot of the time people wish that other people and themselves knew how to write code that is more modular. But again, I think this very much comes with experience, that once you write a lot of code and you figure out a lot of different ways to express your logic, you slowly realize that there are some functions that you should have and like some tricks in order to know when you can increase your modularity. For me, I found that one of the ways is if you're doing something like this, where you have code where you have to put a comment to tell people what your code block does. So you can see here, I've put a comment that tells people that this first code block obtains text and removes punctuation and wildcards, then split into string array of individual words. I had to comment that this code block removes duplicate words. This code block adds unique words to the concordance. And so you would think that, okay, that since I am already describing what this code block does, I should just put this code block into a function, right? So there should just be a function over here that just like obtain and clean text. Here you can like remove duplicate words. Here, add unique words to concordance. Just make them a function. And now I can unit test this function. And also my code becomes much more readable because the people reading it don't have to see this giant block of code. And they'll just see one nice function over there. So again, I think this very much comes with experience, but this is one of the ways that I've like guided the way I do modularity, which is that if you need to tell people what your code block does, yeah, maybe you should make it a function, right? Yeah, just maybe. I don't know. I've never heard this from someone else, but it's sort of my observation. Yeah. Okay, next thing. Actually, that's it for tips in terms of the long form. But I think it's also quite important when you talk about clean code that to remind people that rules are meant to be broken. Because ultimately, I think a lot of the time when you're expressing code, it really depends on the context, how clean you want to be. Like if you're in a competitive programming competition where you only have like 5 minutes to implement something, it doesn't make sense for you to think about your variable names or like write really long docstring. You should just try and like do the thing as fast as possible, and like who cares about the variable names, right? Because like you're not going to be reading it after the competition, and even if you are, it's more important that you complete the task instead of making it maintainable. And so there's also a line between coding defensively and just being paranoid, right? Like when people write functions, a lot of the time they tell you it's a good idea for you to check the inputs to make sure that they are not erroneous. Like for example, if you have a flag like type where the type can only be input and output, you should have an assert statement at the front that checks to make sure that the type is input and output, and to return the appropriate error if the user has specified the variable wrongly. But I think there's also sometimes you can be paranoid and check too many things that don't make sense. Like if you write a function that does binary searching, it doesn't make sense for you to write a line that makes sure that the array is sorted, because checking an array is sorted is in on time, whereas the bisection is in log n time. And so you made your code worse just because you are paranoid that people would use your function wrongly. So I guess there's definitely a line there that is drawn somewhere, but it's very much up to context where that line is drawn. And a lot of the time, I think you shouldn't slow down your time to MVP just so that your code is clean, is more clean. Like if you need to deliver something in a week, it's like, I think it's fine. Like you can code a bit dirty. Like the excuse always given is yeah, like we'll sacrifice this week and we'll come back to refactor. I know, like famous last words, kiss of death. No one ever comes back to refactor. But I guess if you have a good manager, they understand this concept of tech debt and the fact that yeah, sometimes you need to deliver things fast and you need to take some periods where you just pay off your debts before they accumulate and eventually collapse your company. And so I think if you have a good manager, you very much can get away with sometimes being a bit dirty and coming back to refactor. If you don't have a good manager, I guess go back to what Shweta said, all about communication. You're going to have to figure out a way to communicate that you need time to refactor and remove those little things that accumulate over time and eventually make your code really hard to maintain. Okay, the other thing is that I think writing clean code is a habit. And just like any habit, you should start small and start slowly. Like I've given like 4 tips here about like naming and comments and stuff. But I think like after this talk, you shouldn't like once you sit down and code and try to do everything at once, like, oh, I'm gonna name my variables properly, I'm gonna put my comments and tell people why I'm doing things, I'm gonna write all my docstring perfectly, and I'm gonna modularize all my code. Like it's just unrealistic, and I think you're very much going to like be burnt out and realize that that's a very big jump to go. And so I think very much you should just pick things up slowly, right? Like for 1 week, just be like, okay, for this week while I'm coding, I will be more conscious of the way I name variables. And then over time, this becomes a little bit of a habit and you name your variables a bit better. Then the next week you can go like, okay, I'm going to try and put my comments in a more informative way. And you slowly pick up and realize where you should be putting comments. Like when you write lines of code, you think about, okay, will me from 2 weeks later know why I wrote this line of code? And if I don't expect me from 2 weeks later to know why I wrote this line, I should probably put a comment here. These kind of small habits that you develop over time, and then at some point they don't become a very conscious effort from yourself, and then eventually you get to write clean code. And so it very much is going to feel weird at the start, and you're going to be Googling a lot about how your language works. Like, I think a lot of the time people don't write clean code because they don't know all the features of their language, or they don't know the way that their language was designed. One of the common examples I think all the Python developers laugh at is you'll see that when people move from learning C or Java and they move into doing Python, they write their for loops using indexing, which for those of you who don't know, Python has this idea of Pythonic for looping, because one of the big errors that happens a lot, one of the semantic errors, is an off by one error when you're looping through an array and you miss one element because of the indexing. And so usually we advise people to use the iterators, so that you always make sure that you iterate through every element in that array and it behaves in the way you expect, and you don't have these off by one errors. And so I think this is something that a lot of the time you need to know how your language works in order to write code in a way that the language had intended it to be written. But I think it's a good idea, because like in the process, you will learn about a lot about how your language was designed, how your language works, all the standard library functions that your language has, and ultimately you'll be able to write better code. And okay, so what other resources do you have? I think this one, I think I think it's just something that they don't teach in university, but a lot of developers have realized that this is true, which is that like if you go to learn architecture or you go to learn art, oftentimes your course will include visits to art museums or like visits to whatever architecture conferences, and you go there and you see the work of the masters, and you you see the art students sitting there trying to replicate what the masters have done. And I think that we should do that in software engineering as well. Unfortunately, we don't. For some reason, in university and software engineering, they teach you things with really impractical examples, like, oh, polymorphism. You have a big class called fruit. Fruit has a child called orange. Like, I don't think I think most software engineers aren't ever going to implement a class called orange, and it doesn't make sense in that context that you would have like fruit is the parent of orange. But I guess it's a very idealistic example to be able to teach polymorphism. But I think people don't really know why you need to use it until they've seen a practical example. And one of the ways that you can see more practical examples and try to replicate that in the way you code is looking at code from open source. The reason is that obviously code from open source, being open source, the code is read way, way more than it is written. And oftentimes when the repository gets very big, people are very strict around code cleanliness. You know, they do all the best practices. They have their CI/CD, they have their testing, they have their linting and everything. And so I think reading open source code and the way that people write open source code, I think very much helps in learning how to write clean code and how to use your language in a more professional way, I guess. Yeah. So very much I invite all of you to just read through open source code. Yeah. Okay, so now here's some honorable mentions. These are sort of tips that I've come across, which I think are a bit too specific, so I didn't end up putting them in the talk. But I think are still nice to know things. Like don't use list and tuple as data classes. Like I can't tell you how many times I read data scientist code where they don't write data classes and they use the lists as data classes. So they will give you like a list where the first index in the list is the name, the second index in the list is the description, the next index in the list is a list of transactions. Then inside that list, there's another list with the first index being the bank transaction ID, then the next one being its category and stuff. And this is just really hard to maintain because what you will see is in their code, every reference to data, they use indexes. So like data 0, data 1, data 2. And like looking at that, like I have no idea what data 0, 1, 2 is supposed to be. Like I could reverse engineer it, But obviously, if they had used the data class, they would be referring it to it correctly, because they'll do something like data.name, data.description, data.client ID, and it's just much more readable. So don't use list and tuples as data classes. Don't import star, because this is how you get into cyclic imports. It's when you import way too many things and you don't even know what you're importing at some point. Yeah, I have really legitimately read data scientist code where they import the helper using import star, and they don't actually import pandas in their script because they import pandas through the helper. And like, yeah, I don't think that's a good idea. Okay, just makes your code really hard to read. Don't select star in SQL. This is how you break database migrations. Use type hinting when you can. Don't be too loosey-goosey with types. I mean, it's nice in JavaScript and Python that we have this whole dynamic typing, duck typing thing, but you shouldn't be too free with types, because when your variables can have all sorts of types, you can have all sorts of semantic errors, where when you wrote the function, you expected an int to come in, someone passes in a float, and it just behaves in a way that you didn't expect. And so it's generally good to avoid that and to be more strict about the way you do types. I think the JavaScript community has slowly picked this up. That's why they've been slowly moving to TypeScript. I think Python community has been a bit slower. I guess controversial. Python 3.10 was supposed to have type hinting as default, where you didn't need to import types anymore, and you could do the pipe operator to do unions. Yeah, but I guess Python community very much still likes the dynamic typing thing, but it does weaken the maintainability of the code. The other thing is use assert statements. Use type validation when you can. Again, this one, validation code very much sometimes falls into the paranoid. Don't try to validate everything, but don't validate so less that you get really weird bugs. The next one is to have good defaults, and especially make sure that your defaults aren't fatal. Because a little anecdote, there was a script someone wrote in my company where they wrote async delete variable slash, and the default string for the variable was empty string. And so you think that, okay, come on, when people are using the command, they will always put a parameter, so it's fine. Okay, they will always do what they intended to do. But obviously, this code existed for 3 months. One day, someone entered the command without the parameter, and boom, server gone. Because those of you don't know, that command without the parameter would now evaluate to async dash dash delete slash. So it would delete everything inside the server from the root. And yeah, pretty bad. Having good defaults, again, I think security people are also very adamant about this. Again, I think most of you know the log4j exploit, where you could do remote code execution. Again, this was sort of because it had bad defaults. Yeah, because interpreted logs, I mean, it sounds like a bad idea for most people, but I think it was a very Java thing, because Java has this thing called JNDI, and I don't know, it's an enterprise thing. They really like to import things from servers, yeah, safety reasons. And so they had this JNDI and they put it in their logs, but it was probably a bad idea to make the default be the interpreted. Like the default should have been that this interpreted is turned off, and only for power users who knew that this feature existed and who knew how to use this feature securely, like to let them turn it on so that they could use it, and the default should be off. But obviously the people who designed the log4j did not have this consideration. The default was that the interpreted log was on, and therefore the internet exploded over log4j. Pretty fun. Okay, other thing about data engineering, again, my colleague complained, data scientists like to write notebooks that are idempotent and not idempotent and not sequential. And so yeah, you should try and correct this. Idempotent means that when you execute something multiple times, it still does the same thing. Yeah. So like this is just when you're trying to productionize code from notebooks, you'd ideally want to just be able to copy paste trivially sequentially. But a lot of the times, the data scientists I mean, they're experimenting, and a lot of them aren't software engineers. So they write giant blocks. Not just that, but they write code in which you're supposed to run cell 1, then run cell 3, then run cell 2, change one of the parameters in cell 2, run it again, and then run cell 4. And that's how they execute their code. And like, obviously, this is not maintainable because only the person who wrote it remembers the sequence to execute all the cells. And ideally, when you're writing a notebook, you should try and make sure that running your notebook in sequence actually works. Yeah. Again, what I said before, use iterators or functional expressions instead of iterating using indexes, because the off by one thing. Use library functions when you can, because oftentimes when you use a library function, the library function is well tested. Whereas if you try to write the function yourself, there may be considerations that you haven't thought about that would introduce bugs into your logic. So if there's a library function, a well-tested library function that's out there, probably a good idea to use it. But again, not too many, because you do see projects where they basically import everything from everywhere, and the Docker container that gets built ends up like 5 gigabyte, and like probably not good. Like if you're importing a giant library just to use one function, then maybe just steal the function instead of importing the whole library. Again, use experiment tracking. This happens a lot in production data science, where the models that are created are not reproducible because the data scientist forgot the parameters that he used, because he ran like the model 100 times that day with all sorts of different parameters, but he never tracked them. And then like they could never find back the parameters that he used to train the winning model. So again, I think if you have experiment tracking like MLflow and everything, it tracks all your parameters, tracks all your metrics. This becomes an afterthought. You don't have to be very active in like documenting all your experiments in an Excel spreadsheet or something. Again, what Shota said, write tests. Next thing is pin versions. Again, that's why people have the virtual environments. Make sure that versions don't clash. Again, when you're writing Docker files, make sure you pin the version of the image that you are importing. Don't use latest, because obviously latest is changing every few months. And one day the latest may change that such in a way that it breaks your code. Always try to pin down your versions. Use logger when you can, but apparently not, because sometimes logger has security issues. Okay, further resources. So yeah, there's this nice talk by Brian Kernighan on elements of programming style. This one is a bit more on like scientific coding. Yeah, but I think it's a really nice talk from someone who has been in computer science for a long time. Documenting Python code. This is an article on Real Python about how to write doc strings in Python. There's a Zen of Python, which you can see by, if you have the Python interpreter, just import this. It will show you the Zen of Python. So just a few guidelines on coding practices that Python people have. There's this nice talk by Chris Gurvey about object-oriented design and testing patterns in machine learning. Yeah, I'm not sure if I copied her full talk name, but yeah, in here she was talking about specific object-oriented design in the context of ML ops. Yeah, and another resource, I think, just to get better at writing clean code is to just write more code. Yeah, just make more mistakes. I think a lot of the time, like like giving advice always has this double-edged thing of like the people receiving the advice don't have the experience of the person giving it. And a lot of the time you don't think it's that important. Like, come on, I've never faced that myself. And like it only becomes important to you once you've been put in that spot. And so yeah, I think just write more code and make more mistakes, and over time pick up more best practices to have. And yeah, that basically concludes my talk. And yeah, I'll open it up to questions.
Thanks, Jack. I'm
should
not
get the
sure if you
sound
can
working.
hear me, but
I'll do this with the
I'll just
sound.
bring up the questions for you. Are you able to see the screen?
Yes. Okay, I think the sound works now.
Okay, great. Yeah, so we have one question from Mang Un asking, how we handle biased, unbalanced labeled data in order to improve ML fairness. I believe it's directed for you. So yeah, do you want to take that question?
Okay, sure. I think this question
I
is
think it's
probably more
probably, yeah.
yeah, at her session. Yeah. But for this one, I think it's on auditing. So you'd want to make sure that the way that you do model evaluations very much takes into account fairness. Like there's a paper on it. I forgot by who. There's about like testing NLP models and making sure that the NLP models weren't being racist. And basically, the idea was that you would have examples in your evaluation set that test for specific properties that you want to have in your model. And so making sure that it's fair and making sure that it's ethical, and to make sure that even if the population you're trying to protect has a low prevalence in your data, that you can still surface that there may be a problem with your model regarding the protected population. Yeah.
Yeah. Thanks for answering that, Jack. I believe that Shweta did mention as well, like during her session. So yeah, I guess like to probably like summarize what she said earlier was like so one would be probably to fix, I mean, resample our training data set itself. And yeah, I'd say that another thing we could look at would be also, how we are going to evaluate the um, the metrics itself, like how we want to fix what we want to give more importance to. So that would probably help as well. So yeah, she did answer this question as well, like yeah, probably we didn't get the probably because of the lag we didn't get the question earlier, but yeah. Yeah, apart from that, thanks a lot, Jack. We have someone sharing this. Okay. Yeah, to be honest, I completely agree with this because I feel like all of us are guilty for the things that Jack mentioned earlier. So, I mean, I'm pretty sure most of us here have done at least, I'm pretty sure more than one of those mistakes mentioned. And I really like the part where he did mention that, you know, when you write your code and you're trying to comment it, so write why instead of like what you've written. I feel like that's like something that many of us tend to miss out. So when it comes to commenting, we tend to just write stuff like what the code does, when we kind of forget that you know the next person is going to look at it, they probably understand as well. All they need to know is like why you're doing this, right? So yeah. So that's definitely something to keep in mind. And yeah, thanks a lot, Jack. I'm pretty sure this is um very very quality stuff that you've shared. Like many of us, we tend to overlook this. We get excited when we're going to learn something new and stuff. We forget about the basics itself that we should improve on. So yeah, this is something else that we got on the comment. I think there's another question here as well, asking what tool in GCP do you automate an ML pipeline from data ETL to ML serving? Jack, do you have anything in mind that you want to share, or should I take this?
For this, I'm not sure about GCP because my company doesn't use GCP, but one of the open source serving tools is something called Bento ML. Yeah, so Bento ML very much takes your models and puts it's a nice wrapper around it that puts a good API and like good documentation. Yeah, so you may want to look into Bento ML.
Yeah, apart from that, I'd say that Kubeflow is also probably something that you might want to check out. There are many other, stuff that you can look into as well. So if, yeah, any of you are interested, you can always familiarize yourself with, the Quick Labs platform itself. Now it's been rebranded to Cloud Skills Boost platform instead. So yeah, I could probably just put in the URL and you could go through the different parts that you can refer to as well. Just a moment, let me get that for you guys. yeah, I've put that in the chat. So yeah, if you're interested in ML ops or you generally, like, if you're into the security part and stuff, so there are many different parts that you can refer to via this link. So yeah, feel free to check that out. Yeah, I think that's about it for our Q&A session. Jack, do you have any um you know quick tip before we end today's session? Anything you want to share?
Not really. But just
Okay.
again, I think I hope you guys enjoyed the talk. And again, I think it's something that's not very often talked about because it's not very flashy. It's not like newest technology, but I think it's just something that improves like developer experience overall. Just being able to write code that is more maintainable. That a month later, when you look back, you know why you wrote the code instead of it just telling you what. And it's like, oh yes, I know the language. I know what it does, but I don't know why I did it. Yeah, so.
Absolutely. I can tell the number of times I've spent a very, very long time just trying to understand what someone has written, just or at least even like what I've written months back, just trying to figure out what I've written. So this is definitely something essential for most developers. So thanks again, Jack, for joining us today and for this talk. Yeah, never have I like thought of this idea, so thanks for coming up with this idea as well. So once again, thank you, and we hope that we'd have many more sessions with you where you can share about these best practices. Because I have noticed that Jack always comes up with these ideas that most people tend not to even you know identify. So thanks a lot, Jack.
It's just I'm a very in content person because very much I think the talk spawns from me in my internship reading data scientist code and just being like, oh come on. I don't even know what types you are trying to put into this function and like wow, all these indexes, what are you trying to refer to?
I guess then you having more problems would help out the community.
Yeah, I hope so. I hope so.
All right, then. Thanks a lot, Jack.
Okay,
All
thank
right,
you.
so
Thanks for
we
having
can
me.
move on to the next session. Okay, so um, we're done with our talks for today. So we had hands-on demo, we had lightning talks and presentations. So I hope that all of you have something to take away from this, and I hope that you have gotten a wonderful virtual DevFest experience this year. We hope that at least next year we would be able to meet all of you in person. We definitely wanted that this year as well, but we just want to take safety precaution. So once again, if any of you have not filled up the form to win the swags earlier, feel free to check the live chat where we have put in the link to the form, so you can fill in the form and stand a chance to win some, GDG Cloud, swags. So yeah, we have some comments here. Oh, okay. Yeah. Apart from that, we have another final session where we would like to give away something more special. So right now we're gonna have a game, and yeah, Jingying would be moderating it. Let me just bring in Jingying. Okay. Jingying, whenever you're ready. So yeah, we're gonna play this Kahoot game, which Jingying has helped me prepare. And yeah, so the winners of this game would get a Google Home Mini. So I hope you guys are all super excited for this, and yeah, all the best. So I guess I'll hand it over to Jinging. Okay. Yeah, so all of you can just sign up to Kahoot, and
I think we can wait
yeah.
for more participants.
Yeah, sure. I'll leave it to you, Jinging. Okay. Once again, just a reminder for the winners, we can only give the gifts to the ones in Malaysia. That's quite a challenge for us, to ship it overseas. So I hope all of you are in Malaysia, the ones of you who are playing. So for those of you who are wondering like what the game would be about,
Okay,
so it's
should I
mainly
start
gonna
now?
be, yeah, sure. I think we can wait for a bit. I think there are still people. Okay. Yeah. Oh, I think someone dropped off. Not sure what's wrong. I guess we can give like another 3 minutes and then we can start the game. Yeah, so the questions would be mainly on Google Cloud, machine learning, some simple best practices, and a little introduction to these platforms. So I think by 3:30 we can start. Also, just a reminder, apart from answering the questions correctly, I believe that Kahoot also looks into the speed of answering the questions. So yeah, that's something you might want to keep in mind. So we'll be starting in a bit. So for those of you who are online, yeah, it'd be great if you could log in sooner. Okay, we have another. Okay, we could probably give it another minute and then we can start with the game. So yeah, if anyone just joined, the winner would get a Google Home Mini. So you might want to consider joining. And yeah, I think we can start in a minute, Jingy. Yep, I think we're good to go.
Alright, I'll start now.
Okay.
Congratulations.
That's pretty impressive, guys. 15 out of 16. Okay, so congratulations to HY. I guess that's Hoyu. Is that you, Hoyu? I don't know. Elaine and Jack Jack, thanks a lot for participating, everyone. I hope you guys had a good experience. And yeah, to the three of you, we'd appreciate it if you could send us an email at GDG Cloud KL gmail.com, so you can put our email in the chat. So we'd appreciate it if the three of you could send us a screenshot and just post it in our email and let us know who you are. So yeah, I'll just keep in mind who the three winners are. Okay, so yeah, to our winners. It was Fayu, so congrats, Fayu. Yeah, so for these three winners, you'll be getting a Google Home Mini. As for the rest of you, don't be disheartened. Just fill in the form that we shared earlier. You can fill that in and get your swags. We will be sharing it to. We will be sending it over right to your doorstep. So don't worry about that. Yeah, let me just bring in these. Well, yeah. So once again, thanks everyone for joining us. We had a great time, hosting this, and it has been amazing having such, you know, interactive participants as well. So we don't feel like we're talking to ourselves, and we know that you guys are there. So that was really fun. I hope you guys had a good experience, just like how we had. So yeah, Jinging and Z, do you have anything to share with our participants today before we end today's session?
Super happy to have all of you here, and if you are interested, please stay tuned for our future events. And also, if you are a student, feel free to join us GDSCUM. Yeah, no matter what university you are from, we welcome you.
All right, thanks Z for sharing that. Jinging, do you have anything to share?
And thank you everyone for joining this.
All right. So
Yeah, I
yeah,
think that's
thanks
all.
again. Okay. Yeah, thanks again everyone for joining. Yeah, just before we end today's session, we want to share once again about um, our community partner Turing. So Turing.com does help the world's most exceptional developers with more than 3 years of professional experience in Android, Flutter, Angular, Google Cloud, and name it. All these skills, to find long-term and full-time remote jobs with leading US tech firms. So Turing's Intelligent Talent Cloud uses AI to connect the world's best senior software developers to high-quality remote US jobs. So we have shared with you guys, the links that might be useful. I think it has come into like segments because of the length of our message. So you can always reach out to us if you have anything interested. Like if you want to look for remote jobs as well, we can connect you with Turing.com. And yeah, we have shared the links in the chat as well. So yeah, let's hope that you guys had a great year this time on. I mean, I know it's been a challenging year, but it has been amazing having all of you, even if it's just virtually. I feel that it's given us a great opportunity to connect with speakers from different parts of the globe. We had, Gwenny coming from Australia and Shweta from India and Anandan from US. So yeah, it was amazing to have this amazing lineup of speakers today, and a very diverse one, if I may say. So once again, Happy New Year, everyone, and Merry Christmas. I hope that you enjoyed, and we look forward to seeing all of you in our future events as well. So, yeah, one last time before we end today's session, just a quick reminder to the three winners: send us an email mentioning, you know, that you have joined this thing and that you've won. So, I think there's someone. Okay, so yeah, this is something that someone has shared, and yeah, I guess like it's a good reminder for us to um, be prepared before we go for the interviews. So yeah, that's about it. So thank you everyone, and I guess we'll all see each other next year. So this is the last event for GDG Cloud KL for this year. Yeah, feel free to share your experience with us on social media. Hit us up on social media if you have any questions. And for those of you who did not fill in the form for these swags initially, and for those of you who probably didn't win earlier, just feel free to fill in the Google form that we've shared in the chat previously. And yeah, you might be one of the lucky winners to receive those swags. So thanks everyone, and have a great weekend. Happy New Year and Merry Christmas.